The story of Atlantis has captivated human imagination for thousands of years, but what if I told you that recent archaeological discoveries are challenging the boundary between myth and reality? The tale of Atlantis first emerged from the writings of the Greek philosopher Plato in his dialogues Timaeus and Critias, written around 360 BCE. Plato described Atlantis as a powerful island civilization that existed approximately 9,600 years before his time. But was this merely a philosophical allegory, or was Plato preserving an ancient historical account? In recent years, archaeological evidence has begun to emerge that suggests there might be more to this story than previously thought. The first breakthrough came in 2017 when marine archaeologists discovered unusual geometric patterns on the seafloor near the Bimini Road in the Bahamas. These structures, lying at a depth of 80 feet, display remarkable architectural precision that would have been impossible to achieve without advanced engineering knowledge. What makes these findings particularly intriguing? Let's examine the key elements. Architectural precision. The discovered structures feature perfect 90-degree angles and sophisticated geometric patterns that mirror those described in Plato's accounts. How could ancient civilizations achieve such precision underwater? Material analysis. Laboratory tests conducted on samples from these structures revealed a unique form of concrete-like material composed of elements not typically found in natural formations. The material's composition suggests artificial creation using advanced techniques that weren't supposedly available to ancient civilizations. Dating evidence. Carbon dating of organic materials found within the structures places their construction at approximately 11,600 years ago, remarkably close to the timeline mentioned by Plato. This correlation has forced many historians to reconsider their skepticism about Plato's account. The discovery also revealed something even more remarkable, what appears to be an ancient gateway structure. This massive architectural feature, standing 30 feet high and 45 feet wide, bears inscriptions in an unknown script that shares similarities with both ancient Egyptian hieroglyphs and early Phoenician writing. But here's where it gets even more interesting. The gateway appears to be part of a larger complex that extends deeper into the ocean floor. Why is this gateway so significant? Several factors make it extraordinary. Technological implications. The gateway's construction would have required engineering capabilities far beyond what we believed possible for civilizations of that era. How did they achieve this? Cultural significance. The mixture of writing systems suggests a civilization that either predated or influenced multiple known ancient cultures. Could this be evidence of a mother civilization? Geographical location. The position of the gateway aligns perfectly with ancient maps that supposedly showed the location of Atlantis, particularly those referenced in the Egyptian Hall of Records. The discovery has led to the formation of the International Atlantean Research Project, IARP, a collaborative effort involving archaeologists, marine geologists, and historians from 23 countries. Their ongoing research has revealed several fascinating details. The gateway structure contains traces of an unknown metal alloy that remains resistant to corrosion despite millennia underwater. How did they develop such advanced metallurgy? Acoustic studies of the gateway reveal unusual properties. It appears to amplify certain sound frequencies in a way that suggests deliberate design. What was the purpose of this acoustic engineering? Surrounding the gateway, researchers have found evidence of advanced water management systems, including what appears to be an ancient form of hydraulic engineering. But perhaps the most compelling aspect of this discovery is what it suggests about human civilization's timeline. Traditional archaeological theories propose that advanced civilization began around 6,000 years ago in Mesopotamia. However, these findings indicate the existence of a sophisticated society capable of complex engineering and architectural feats thousands of years earlier. This raises several profound questions. How much of our understanding of human history needs to be revised? What level of technology did this civilization possess? What caused their eventual disappearance? The research continues to yield new insights. Recent submarine expeditions have mapped an extensive network of structures extending from the gateway, suggesting a city plan that closely matches Plato's descriptions. Ground-penetrating radar has revealed the presence of numerous buildings and what appears to be a complex road system, all preserved beneath centuries of marine sediment. The Lost Atlantean Gateway represents more than just an archaeological discovery. It's a window into a potentially advanced civilization that existed at the end of the last ice age. As research continues, each new finding adds another piece to this fascinating puzzle, challenging our understanding of human history and technological development. As we conclude this examination of the initial evidence, we must ask ourselves, what other secrets might this gateway hold? What further discoveries await in the deeper waters beyond? The answers to these questions could revolutionize our understanding of human civilization and its capabilities in the distant past. The investigation continues, and with each passing day, new technologies and research methods are being employed to unravel the mysteries of this remarkable discovery. The Lost Atlantean Gateway might just be the key to unlocking the truth about humanity's forgotten past. In our journey to uncover the mysteries of ancient underwater civilizations, modern technology has revolutionized how we explore and understand the depths of our oceans. Have you ever wondered how scientists manage to investigate structures that lie thousands of feet below the surface? Let's dive into the fascinating world of deep-sea exploration and the groundbreaking discoveries it has enabled. The advent of sophisticated sonar systems has transformed our ability to map the ocean floor. Unlike traditional methods that relied on basic depth measurements, modern multi-beam sonar systems create detailed 3D maps of underwater terrain. These systems emit multiple sound beams that bounce off the seafloor, returning data that computers process into high-resolution images. This technology has revealed numerous geometric formations that appear too regular to be natural, sparking intense scientific interest. One of the most significant technological breakthroughs came with the development of autonomous underwater vehicles, AUVs. These unmanned submarines can operate at depths reaching 20,000 feet, far beyond the practical limits of human divers. Equipped with high-definition cameras, sensors, and sampling tools, AUVs have documented extensive networks of what appear to be ancient stone structures. But what makes these discoveries particularly compelling? Remote-operated vehicles, ROVs, have played a crucial role in detailed examination of these sites. Connected to surface ships via umbilical cables that provide power and transmit data, ROVs can stay underwater indefinitely, allowing scientists to conduct thorough investigations. These vehicles have captured evidence of precise stone cutting and complex architectural features that suggest advanced engineering capabilities. The application of photogrammetry in underwater archaeology has been revolutionary. By taking thousands of overlapping photographs, researchers can create accurate 3D models of underwater structures. This technique has revealed architectural patterns that align with known ancient building methods, but at scales that challenge our understanding of prehistoric capabilities. How did ancient peoples achieve such engineering feats? Advanced imaging technologies have also led to the discovery of materials that appear manufactured rather than naturally formed. Magnetometers have detected unusual concentrations of metals within these structures, while side-scan sonar has revealed regular patterns suggesting planned layout and design. These findings raise intriguing questions about the technological capabilities of ancient civilizations. Sediment core sampling, enhanced by modern dating techniques, has provided crucial timeline data. Scientists can now accurately date materials found near these structures, helping establish when they might have been constructed and subsequently submerged. These dates often coincide with known periods of significant sea level changes, adding credibility to theories about lost coastal civilizations. The development of specialized deep-sea lighting systems has dramatically improved our ability to document underwater sites. LED arrays capable of illuminating vast underwater areas have revealed details previously hidden in darkness. These systems have helped identify tool marks, decorative elements, and construction techniques that suggest sophisticated architectural knowledge. Material analysis technologies have also advanced significantly. X-ray fluorescence devices can now determine the composition of underwater materials without removing them from their location. This non-destructive testing has identified stone types that don't naturally occur in these locations, indicating deliberate transportation and construction. Perhaps most exciting is the application of artificial intelligence in analyzing underwater data. Machine learning algorithms can now process vast amounts of sonar and visual data, identifying patterns and structures that might be missed by human observers. These systems have helped map extensive underwater complexes that appear to be planned settlements. Advances in diving technology have also played a crucial role. Mixed gas diving systems and atmospheric diving suits allow human researchers to directly observe sites at greater depths and for longer durations. This direct observation has been vital in verifying and interpreting data collected by automated systems. The integration of GPS and underwater positioning systems has enabled precise mapping of discovered structures. Researchers can now create accurate site plans showing the relationship between different architectural elements, revealing complex geometric patterns and alignments that suggest sophisticated planning. These technological breakthroughs have also improved our understanding of preservation techniques. Scientists can now better analyze how different materials react to long-term submersion, helping distinguish between natural formations and man-made structures that have been altered by centuries underwater. The development of underwater excavation tools has allowed for more precise investigation of these sites. Specialized equipment can now remove sediment without damaging underlying structures, revealing new layers of evidence about construction methods and materials. What makes these discoveries particularly significant is how they challenge our current understanding of ancient technological capabilities. The precision of construction, the scale of the structures, and their apparent age raise compelling questions about the sophistication of prehistoric civilizations. As technology continues to advance, what other secrets might we uncover in the depths of our oceans? The evidence gathered through these modern methods suggests we may need to revise our understanding of ancient human capabilities and the possibility of advanced civilizations lost to rising seas. These technological breakthroughs have not only revealed new evidence, but have also helped verify and expand upon earlier discoveries, creating a more complete picture of these underwater structures. As we continue to develop new tools and techniques, our understanding of these ancient sites grows ever deeper, promising even more remarkable discoveries in the future. In our journey to understand how ancient underwater ruins have survived the test of time, we must turn our attention to one of nature's most remarkable preservationists, coral. Have you ever wondered how structures that should have eroded away centuries ago still stand proudly on the ocean floor? The answer lies in the fascinating relationship between coral formations and submerged archaeological sites. Coral, these tiny marine architects, play a crucial role in preserving underwater ruins through a process known as coral encrustation. When ancient structures sink beneath the waves, they become potential attachment points for coral polyps. These microscopic organisms settle on the stone surfaces and begin their gradual work of preservation. But how exactly does this process work? The preservation process begins immediately when coral larvae, called planulae, attach themselves to hard surfaces of sunken structures. Once attached, these larvae develop into polyps that secrete calcium carbonate, effectively creating a protective layer around the structure. This natural coating serves as armor against the erosive forces of the ocean, including strong currents, saltwater degradation, and marine-boring organisms. What makes this preservation method particularly effective is its self-sustaining nature. As each generation of coral dies, it leaves behind its calcium carbonate skeleton, upon which new coral polyps build. This continuous cycle creates multiple layers of protection around the original structure. The process is so effective that many ancient ruins have remained largely intact for thousands of years, protected beneath these living shields. One of the most significant examples of coral preservation can be found in the ancient port city of Port Royal, Jamaica. After an earthquake in 1692 submerged portions of the city, coral formations began colonizing the structures. These coral formations have helped preserve everything from building foundations to personal artifacts, providing archaeologists with an unprecedented window into 17th century maritime life. The relationship between coral and underwater ruins goes beyond mere preservation. Coral formations can also help archaeologists date structures and understand sea level changes throughout history. How? The growth rate of certain coral species is well documented, allowing researchers to calculate how long a structure has been submerged by measuring the thickness of coral layers. Additionally, different species of coral grow at specific depths, providing clues about historical sea levels and how they've changed over time. Temperature and water conditions play crucial roles in this preservation process. Coral thrives in warm, clear waters with specific salinity levels, typically found between 30 degrees north and south of the equator. This explains why many well-preserved underwater ruins are located in tropical and subtropical regions. The Mediterranean Sea, the Caribbean, and the Indian Ocean are particularly rich in coral-preserved archaeological sites. However, this preservation method isn't without its challenges. Modern threats to coral reefs, including ocean acidification, rising sea temperatures, and pollution, also threaten these preserved ruins. When coral dies, it stops building new protective layers, potentially exposing ancient structures to erosive forces. This makes the conservation of coral reefs not just an environmental concern, but also an archaeological one. The scientific community has developed various methods to study these coral-preserved ruins without disturbing their protective coating. Advanced sonar mapping, underwater photogrammetry, and non-invasive sampling techniques allow researchers to document and study these sites while maintaining their integrity. These methods have revealed intricate details about ancient construction techniques, trade routes, and maritime activities that would have otherwise been lost to time. Understanding the role of coral in preservation has also influenced modern marine archaeology practices. When new underwater sites are discovered, researchers often choose to leave structures in place rather than attempting to recover them, recognizing that the coral's protective environment offers better preservation than many land-based alternatives. The coral's preservation capabilities extend beyond just stone structures. In many cases, coral formations have helped preserve wooden shipwrecks, metal artifacts, and even delicate items like ceramics and glass. The anaerobic environment created within coral formations can prevent the deterioration of organic materials, providing invaluable insights into ancient maritime technology and trade. Looking ahead, the study of coral-preserved ruins continues to evolve with technology. Researchers are now using artificial intelligence to analyze coral growth patterns and predict which underwater sites might be at risk from environmental changes. This information helps prioritize conservation efforts and documentation of threatened sites. The relationship between coral and underwater ruins reminds us of the intricate connections in marine ecosystems. What started as a simple process of marine organisms seeking suitable surfaces for growth has become one of archaeology's most valuable preservation tools. As we face increasing threats to coral reefs worldwide, the urgency to study and protect these natural time capsules grows stronger. The Coral Chronicles teach us that preservation often comes from unexpected sources. These tiny marine architects have not only created some of the ocean's most diverse ecosystems, but have also become the guardians of our underwater cultural heritage. Their role in preserving our maritime history adds another compelling reason to protect and preserve coral reefs for future generations. Let's dive deep into one of the most fascinating aspects of underwater archaeology: the intricate process of decoding ancient inscriptions and artifacts found beneath the waves. Have you ever wondered how researchers piece together the stories of civilizations lost to the sea? The answer lies in a combination of cutting-edge technology and traditional archaeological methods. When archaeologists discover underwater inscriptions, they face unique challenges that their land-based colleagues don't encounter. The constant exposure to saltwater, marine organisms, and underwater currents can significantly alter or damage these ancient writings. But how do they overcome these obstacles? The process begins with careful documentation using specialized underwater photography and photogrammetry techniques. These methods allow researchers to create detailed 3D models of inscriptions without physically disturbing them. One of the most significant breakthroughs in underwater inscription analysis came from the development of multispectral imaging technology. This technique uses different wavelengths of light to reveal text and symbols that are invisible to the naked eye. Think about it: inscriptions that have been hidden for thousands of years, obscured by marine growth or erosion, can now be read with remarkable clarity. This technology has been particularly valuable in studying shipwreck artifacts, where cargo manifests and ship's logs provide crucial information about ancient maritime trade routes. The translation process itself is a meticulous endeavor. Underwater inscriptions often combine multiple ancient languages and writing systems, reflecting the international nature of maritime trade throughout history. Researchers use comparative linguistics and established archaeological databases to decode these messages. For instance, bilingual inscriptions, similar to the famous Rosetta Stone, have been found underwater and have helped scholars understand previously unknown writing systems. But what about the artifacts themselves? Each object tells its own story, and underwater preservation can sometimes be superior to land-based preservation. The lack of oxygen in deep waters can prevent organic materials from decomposing, giving archaeologists unprecedented access to ancient wooden objects, textiles, and even food items that would have long since disappeared on land. The analysis of underwater artifacts requires specialized laboratories equipped with desalination tanks. Why is this important? Because when artifacts are brought to the surface, the sudden change in environment can cause rapid deterioration. The desalination process gradually removes salt from the objects, preventing damage and preparing them for detailed study. Modern technology has revolutionized how we date underwater artifacts. Beyond traditional carbon dating, researchers now use advanced techniques like thermoluminescence, dating for ceramics, and dendrochronology for wooden objects. These methods provide precise chronological frameworks for understanding maritime trade and cultural exchange. One of the most exciting aspects of underwater artifact analysis is the study of ancient technology. Shipwrecks, in particular, provide invaluable insights into historical engineering and navigation methods. Researchers have discovered sophisticated navigation instruments, advanced ship construction techniques, and complex cargo storage systems that challenge our assumptions about ancient technological capabilities. The field of underwater epigraphy, the study of inscriptions, has revealed fascinating details about ancient maritime law, commerce, and social structures. Cargo labels, ownership marks, and religious dedications found underwater help reconstruct the complex networks of Mediterranean, Asian, and Atlantic maritime trade. Did you know that some underwater inscriptions have even helped archaeologists locate other submerged sites mentioned in ancient texts? Digital reconstruction has become an essential tool in this field. Using advanced computer modeling, researchers can virtually reassemble fragmented artifacts and inscriptions, making connections that might be impossible to see in their current state. This technology also allows for the creation of detailed databases that can be shared globally, enabling collaborative research across international boundaries. The study of maritime artifacts has also revealed surprising connections between ancient civilizations. Trade items found far from their origin points have helped map extensive maritime networks that existed thousands of years ago. For example, Chinese porcelain found in East African underwater sites proves direct maritime trade between these regions during the medieval period. Conservation of underwater artifacts presents unique challenges. Unlike land-based finds, materials recovered from the sea require specialized treatment to prevent deterioration. How do conservators achieve this? They use techniques like freeze-drying for organic materials and electrolysis for metal objects, ensuring these precious artifacts survive for future study. The analysis of underwater inscriptions and artifacts continues to evolve with new technologies. Remote-operated vehicles, ROVs, equipped with high-definition cameras and sampling tools can now explore depths previously inaccessible to human divers. This has led to discoveries in deeper waters, expanding our understanding of ancient maritime activities. What makes underwater archaeology particularly valuable is its ability to preserve context. Unlike many land sites, underwater sites often represent single moments in time. A shipwreck, for instance, provides a snapshot of life at the exact moment the vessel sank. This frozen-in-time quality allows researchers to study artifacts in their original context, providing invaluable information about how they were used and transported. The future of maritime archaeology looks promising with the development of AI-powered translation tools and advanced imaging systems. These technologies are making it possible to analyze larger datasets and identify patterns that might be missed by human researchers. As we continue to explore the depths, what other secrets will we uncover about our maritime past? Remember, each artifact and inscription recovered from underwater sites adds another piece to the puzzle of human maritime history. Through careful study and preservation, these silent witnesses to the past continue to tell their stories, helping us understand the complex networks of trade, culture, and technology that connected ancient civilizations across the world's oceans. Have you ever wondered what life was like in ancient coastal settlements that now rest beneath the waves? The story of submerged societies is far more complex and fascinating than most people realize. Let's dive deep into the daily lives of these remarkable communities that time and tides have hidden from view. Archaeological evidence has revealed numerous submerged settlements worldwide, from the Mediterranean to the Indian Ocean, each telling its own unique story of human adaptation and survival. These communities didn't simply disappear overnight. They lived, thrived, and developed sophisticated ways of life that were intimately connected to both land and sea. One of the most well-documented examples is Pavlopetri, off the coast of southern Greece, which was inhabited from about 3500 BCE until 1100 BCE. The settlement's remarkably preserved remains show us a highly organized urban center with streets, buildings, and courtyards. But what's truly fascinating is what these remains tell us about daily life. The layout of homes reveals that families lived in two-story buildings with multiple rooms, suggesting a complex social structure and family life not unlike our own. What did these people eat? Archaeological evidence shows a diverse diet that combined marine and terrestrial resources. Fish bones found in household remains indicate regular consumption of various fish species, while storage vessels contain traces of olive oil, wine, and grains. This tells us these weren't just simple fishing villages, but sophisticated communities that practiced agriculture and engaged in trade. The working life in these settlements was equally complex. Tool marks on stones and preserved artifacts show that people worked as stonecutters, potters, weavers, and boat builders. But perhaps most intriguingly, they developed specialized tools and techniques for working in coastal environments. For instance, they created innovative systems for salt production, which was a valuable commodity for preserving food and trading. How did they handle the challenges of living so close to the sea? Evidence shows sophisticated water management systems, including wells that were designed to prevent saltwater intrusion and buildings oriented to protect against prevailing winds and waves. These communities understood their environment intimately and adapted their architecture and infrastructure accordingly. The social structure of these settlements is revealed through their burial practices and public spaces. Community gathering areas, religious structures, and differentiated housing sizes all point to a hierarchical society with distinct social classes. But unlike many inland communities of the same period, these coastal settlements show evidence of more fluid social mobility, possibly due to the opportunities provided by maritime trade. Children's lives in these settlements are particularly interesting. Toy boats, small fishing nets, and miniature pottery suggest that young people were gradually introduced to maritime skills and traditions. Education appears to have been practical and hands-on, preparing children for life in a coastal community from an early age. What about their spiritual life? Religious practices in these settlements often combined elements of land and sea. Shrines and temples have been found with offerings related to both agricultural and maritime activities, suggesting a worldview that balanced these two crucial aspects of their existence. Trade was a crucial part of daily life, as evidenced by artifacts from distant locations found in these settlements. The presence of foreign goods, from pottery to precious stones, indicates these communities were part of extensive maritime trading networks. But how did they organize these networks? Archaeological evidence suggests the existence of designated marketplaces and storage facilities specifically designed for trading activities. The role of women in these societies appears to have been more prominent than in many contemporary inland communities. Tools and artifacts associated with both maritime and domestic activities have been found in women's burial sites, suggesting they participated in various aspects of community life, from fishing to commerce. One of the most remarkable aspects of these settlements is their resilience. Evidence shows many of them survived multiple natural challenges, from storms to changing sea levels, by constantly adapting their building techniques and lifestyle practices. This adaptability was likely a defining characteristic of their daily life, requiring constant vigilance and innovation. What ultimately led to these settlements becoming submerged? The answers vary by location, but common factors include gradual sea level rise, land subsidence, and in some cases, sudden geological events. However, what's most interesting is that many communities showed remarkable adaptation to gradually changing conditions, often rebuilding and adjusting their structures multiple times before final abandonment. The legacy of these submerged societies continues to inform our understanding of human adaptation to coastal environments. Their solutions to challenges like water management, coastal erosion, and sustainable resource use remain relevant today as modern coastal communities face similar challenges due to climate change. What can we learn from these ancient coastal dwellers? Their story is one of remarkable adaptation, innovation, and resilience. It shows us that human communities have long found ways to thrive in challenging environments through ingenuity and cooperation. As we face our own environmental challenges today, these lessons from the past become increasingly relevant and valuable. Have you ever wondered how ancient civilizations managed to build entire cities underwater? The engineering achievements of underwater city construction represent some of humanity's most remarkable accomplishments, combining innovation, necessity, and extraordinary technical skill. Let's begin by understanding the fundamental challenges these ancient builders faced. Water pressure, material durability, and structural integrity were just the beginning of their concerns. Unlike building on land, underwater construction required entirely different approaches to foundation laying, material selection, and construction techniques. The first crucial element in underwater city construction was the selection of suitable building materials. Ancient engineers discovered that certain types of stone and coral-based materials actually became stronger when submerged in seawater. They utilized naturally occurring underwater limestone formations as foundations, working with, rather than against, the marine environment. This practical approach meant that structures could withstand enormous water pressure while remaining stable for centuries. But how did they manage to create watertight structures? The answer lies in their innovative use of hydraulic concrete, a material that actually hardens underwater. Archaeological evidence shows that ancient builders developed specialized mixtures containing volcanic ash, lime, and seawater-resistant aggregates. This revolutionary material allowed them to construct buildings that would remain intact despite constant exposure to corrosive saltwater. The engineering of underwater foundations presented another significant challenge. Ancient builders developed a technique known as cofferdam construction, where they would create temporary dry areas underwater by building watertight enclosures. These cofferdams allowed workers to lay foundations and build initial structural elements in relatively dry conditions. This method was particularly crucial for larger buildings and public spaces. What about ventilation and lighting? Ancient underwater architects designed intricate systems of air shafts and light wells that utilized natural water currents and refracted sunlight. They created networks of interconnected chambers that maintained air pressure while allowing fresh air circulation. These systems were so well designed that many continue to function effectively for centuries. The construction of underwater transportation networks was equally impressive. Ancient engineers developed a system of tunnels and passages that connected different parts of their cities. These weren't simple corridors. They were carefully engineered to prevent flooding while allowing easy movement of people and goods. The tunnels often incorporated clever airlocks and pressure equalization chambers, concepts that we still use in modern underwater construction. Water management systems in these underwater cities were particularly sophisticated. Engineers designed complex networks of channels and reservoirs that controlled water flow, prevented flooding, and maintained stable pressure throughout the structure. They created innovative filtration systems using layers of sand, gravel, and specially selected marine plants to purify water for drinking and everyday use. The scale of these underwater architectural achievements is truly remarkable when you consider the limited technology available at the time. How did they move massive stone blocks underwater? Archaeological evidence suggests they used a combination of floating platforms, leverage systems, and the water's natural buoyancy to their advantage. They developed specialized tools and techniques specifically for underwater construction, many of which remained secret knowledge passed down through generations of master builders. One of the most fascinating aspects of underwater city construction was the development of public spaces. Engineers created large communal areas that served as marketplaces, gathering spots, and ceremonial centers. These spaces required careful planning to ensure proper ventilation, lighting, and structural support while accommodating large numbers of people. The architectural design also had to account for marine life interaction. Buildings were constructed to resist biofouling, the accumulation of marine organisms on surfaces, while maintaining harmony with the underwater ecosystem. Some structures even incorporated living coral as part of their design, creating a symbiotic relationship between the built environment and natural marine systems. The legacy of these underwater architectural marvels continues to influence modern marine engineering. Many of the principles developed by ancient builders, from pressure management to material selection, are still relevant today. Current underwater construction projects often reference these historical achievements for inspiration and practical guidance. What makes these architectural achievements even more remarkable is their longevity. Many underwater structures have survived for centuries, withstanding not only the constant pressure of water, but also earthquakes, storms, and changing sea conditions. This durability testifies to the extraordinary skill and foresight of ancient underwater architects and engineers. The engineering feats of underwater city construction represent a remarkable chapter in human innovation. They demonstrate how ancient civilizations overcame seemingly impossible challenges through ingenuity, observation, and practical problem solving. These underwater cities stand as testament to human determination and technical brilliance, proving that with the right combination of knowledge, skill, and creativity, even the most challenging environmental conditions can be conquered. Have you ever wondered how scientists can determine the age of ancient artifacts found beneath the waves? How do they piece together the timeline of human civilization's relationship with the seas? Let's dive into the fascinating world of underwater archaeological dating methods, where science meets history in the most remarkable ways. When archaeologists discover artifacts on the ocean floor, they face unique challenges in determining their age. Unlike land-based archaeology, underwater finds are subjected to constant movement, chemical interactions with saltwater, and marine biological activity. This makes dating these treasures both crucial and complex. One of the most reliable methods used in underwater archaeology is radiocarbon dating, also known as carbon-14 dating. This technique works particularly well with organic materials like wooden shipwrecks, leather goods, textiles, and human remains. But how does it actually work? Living organisms constantly absorb carbon-14 from the atmosphere during their lifetime. When they die, this absorption stops, and the carbon-14 begins to decay at a known rate. By measuring the amount of carbon-14 left in an artifact, scientists can calculate how long ago the organism died, giving us a precise date range for the artifact. But what about materials that don't contain carbon? This is where other dating methods come into play. Dendrochronology, or tree ring dating, is particularly useful for wooden shipwrecks. Each year, trees form distinctive growth rings, creating patterns that can be matched against known sequences. This method can be incredibly precise, sometimes pinpointing dates to the exact year. Thermoluminescence dating is another powerful tool, especially useful for ceramics found underwater. This method measures the accumulated radiation in objects since they were last heated. When pottery was originally fired, it released all its stored energy. By measuring the radiation that has accumulated since then, scientists can determine when the pottery was made. The marine environment itself provides additional dating clues. Marine organisms that attach themselves to artifacts, such as barnacles and coral, can be dated using various methods. These organisms create layers of calcium carbonate that can be analyzed to determine when they first attached to the artifact, giving us a minimum age for how long the object has been underwater. Stratigraphy, the study of layered deposits, takes on new meaning underwater. Ocean sediments build up over time, creating distinct layers that can help date artifacts found within them. However, underwater stratigraphy is more complex than on land due to water movements and currents that can disturb these layers. LEED 210 dating is particularly useful for more recent underwater finds, covering the past 100 to 150 years. This method is based on the radioactive decay of LEED 210 in marine sediments and can help date modern shipwrecks and more recent archaeological sites. One of the most exciting developments in underwater archaeological dating is the use of DNA analysis. While not a dating method per se, DNA can help establish connections between artifacts and known historical periods by linking them to specific populations or trading routes. The combination of these dating methods allows archaeologists to build comprehensive chronologies of underwater sites. But why is this so important? Understanding the age of underwater artifacts helps us 1. Reconstruct ancient trade routes and navigation patterns. 2. Track the development of shipbuilding technology through time. 3. Understand how climate change and sea level rise affected ancient coastal communities. 4. Document the evolution of maritime warfare and commerce. 5. Verify historical records and discover previously unknown historical events. The challenges of underwater dating are numerous. Saltwater can contaminate samples, making some dating methods less reliable. Marine organisms can bore into wooden artifacts, potentially contaminating radiocarbon dates. Currents can move artifacts from their original context, complicating stratigraphic dating. To overcome these challenges, archaeologists often use multiple dating methods to cross-reference their findings. This approach, known as cross-dating, helps build more accurate chronologies and reduces the margin of error in dating underwater finds. The future of underwater archaeological dating looks promising, with new technologies emerging regularly. Advanced DNA sequencing techniques, improved radiocarbon dating methods, and new applications of existing technologies continue to enhance our ability to date underwater artifacts accurately. But perhaps the most exciting aspect of underwater archaeological dating is how it continues to surprise us. Sometimes, artifacts turn out to be much older than initially thought, forcing us to rewrite our understanding of ancient maritime capabilities. Other times, they help confirm historical accounts that were previously considered legends. As we continue to explore the depths of our oceans, new discoveries await dating and analysis. Each dated artifact adds another piece to the vast puzzle of human maritime history, helping us understand how our ancestors navigated, traded, and lived in relation to the seas that cover most of our planet. The tides of time have preserved countless artifacts in the underwater world, and through these sophisticated dating methods, we can now unlock their secrets and better understand our maritime past. As technology advances and new dating methods are developed, our ability to accurately date underwater finds will only improve, leading to even more fascinating discoveries about our shared human history. Have you ever wondered how ancient civilizations managed to create vast networks of trade across seemingly endless oceans? The story of oceanic trade routes is a fascinating journey through time, revealing how our ancestors mastered the seas to connect distant lands and cultures. Ancient maritime commerce networks were far more sophisticated than many people realize. These weren't just random paths across the waters, they were carefully planned highways of the seas that connected underwater cities and coastal settlements. Let's explore how these intricate networks developed and functioned. The earliest known maritime trade routes date back to around 3000 BCE, when Mesopotamian merchants began regular trading contacts with the Indus Valley civilization. These early seafarers laid the groundwork for what would become extensive networks spanning the Mediterranean, Indian Ocean, and eventually the Pacific. But what made these routes possible? The development of oceanic trade routes relied heavily on several key factors. First was the understanding of seasonal wind patterns, particularly the monsoon winds in the Indian Ocean. Merchants learned that these predictable wind patterns could propel their ships in one direction for half the year and in the opposite direction for the other half. This knowledge was crucial for planning long-distance voyages. Navigation techniques played a vital role in establishing these routes. Ancient mariners used a combination of celestial navigation, studying the stars and sun's position, and coastal landmarks to maintain their course. They've also developed sophisticated tools like the Kamal, an early navigational device used by Arab sailors, and later the astrolabe, which helped determine latitude. The Mediterranean Sea served as one of the most important maritime trading networks in antiquity. The Phoenicians, Greeks, and Romans established numerous port cities and trading posts along its shores. These ports weren't just stopping points. They were vibrant centers of commerce where goods from different regions were exchanged, stored, and redistributed. In the Indian Ocean, trade routes connected the Red Sea and Persian Gulf with India, Southeast Asia, and eventually China. This network became known as the Maritime Silk Road, complementing the Overland Silk Road. Merchants traded valuable commodities like spices, textiles, precious stones, and metals along these routes. The discovery of numerous shipwrecks along these ancient trade routes has provided archaeologists with invaluable information about maritime commerce. These underwater time capsules contain cargo, personal items, and ship construction details that help us understand the scale and sophistication of ancient trade networks. One particularly fascinating aspect of oceanic trade routes was the development of underwater storage facilities and rest stops. In areas where natural harbors were scarce, ancient engineers created artificial harbors and breakwaters. Some civilizations even constructed underwater structures that served as storage depots and safe havens during storms. The impact of these trade routes went far beyond mere commerce. They facilitated cultural exchange, technological advancement, and the spread of ideas and religions across vast distances. Languages evolved to accommodate international trade, with pidgin languages developing in major trading ports to facilitate communication between merchants from different regions. The establishment of these routes required extensive knowledge of ocean currents, weather patterns, and underwater topography. Merchants had to understand the locations of dangerous reefs, shallow waters, and safe harbors. This knowledge was often kept secret and passed down through generations of seafaring families. Trade routes also led to the development of sophisticated financial systems. Merchants needed ways to transfer large sums of money safely across long distances, leading to the creation of early banking systems and credit arrangements. Some ports developed specialized markets and warehouses for specific goods, becoming the ancient equivalent of modern commodity exchanges. The success of these trade networks depended heavily on the cooperation between different cultures and political entities. Treaties and agreements were established to protect merchants and ensure safe passage. Many coastal cities employed specialized pilots who knew local waters and could safely guide foreign ships into harbor. The legacy of these ancient trade routes continues to influence modern maritime commerce. Many modern shipping lanes follow similar paths to those established thousands of years ago, testament to the wisdom of ancient mariners in finding the most efficient and safest routes across the world's oceans. Understanding these ancient trade networks helps us appreciate the ingenuity and courage of early seafarers who ventured into unknown waters to establish connections between distant lands. Their achievements laid the foundation for the globalized world we live in today, where maritime trade continues to be the backbone of international commerce. As we look back at these ancient oceanic trade routes, we can see how they shaped not just commerce, but the entire course of human civilization. They remind us that the seas have always been bridges rather than barriers, connecting people and cultures across vast distances. What other secrets might these ancient trade routes still hold? As underwater archaeology continues to advance, we may yet discover more about how our ancestors mastered the seas and built networks that would shape the world for millennia to come. In the depths of our underwater civilization, spiritual practices and religious structures played a vital role in shaping the cultural identity of aquatic communities. Let's explore the fascinating world of underwater temples and the unique religious customs that emerged beneath the waves. Have you ever wondered how people maintained their spiritual connections while living in underwater cities? The answer lies in the remarkable Temple of the Deep, a network of sacred spaces that served as the cornerstone of underwater religious life. The underwater temples were architectural marvels designed to withstand immense pressure while creating serene spaces for worship. These structures were typically built into natural rock formations or coral reefs, utilizing the existing underwater landscape to create sacred spaces. The main chambers were carefully positioned to capture natural light filtering through the water, creating ethereal patterns that enhanced the spiritual atmosphere. What made these temples truly unique was their adaptation to the aquatic environment. Unlike surface temples, underwater religious structures incorporated special features like pressure equalizing chambers and current control systems. These technical innovations allowed worshippers to gather safely while maintaining the sanctity of the space. The religious practices in underwater cities evolved to embrace their aquatic surroundings. Traditional ceremonies were modified to include elements specific to underwater life. For example, the blessing of the currents became a fundamental ritual where communities would gather to honor the ocean's natural flows that sustained their cities. One of the most significant aspects of underwater spiritual life was the development of water-based meditation techniques. These practices focused on achieving harmony with the surrounding aquatic environment. Practitioners learned to synchronize their breathing with the natural rhythm of the ocean, creating a unique form of underwater mindfulness. The Temple of the Deep wasn't just a single structure, but rather a network of interconnected sacred spaces. Each underwater city typically had its main temple, with smaller shrines scattered throughout the community. These temples served multiple purposes beyond religious worship. They were centers of learning, community gathering, and cultural preservation. Religious artifacts and symbols had to be specially designed for underwater use. Sacred texts were inscribed on pressure-resistant materials, while religious symbols were crafted from corrosion-resistant metals and minerals found in the ocean depths. How did they preserve these important artifacts? Special preservation chambers were developed using advanced water filtration systems to protect delicate items from saltwater damage. The role of religious leaders in underwater cities was particularly interesting. These spiritual guides, often called deep sages, underwent extensive training not only in religious teachings but also in underwater survival and navigation. They were responsible for maintaining the spiritual well-being of their communities while ensuring safe practices during underwater ceremonies. Education played a crucial role in underwater religious life. Young members of the community learned about their spiritual heritage through specialized underwater classrooms within the temples. These educational spaces featured innovative teaching methods adapted for the aquatic environment, including three-dimensional holographic displays showing historical religious events. The Temple of the Deep also served as a repository of cultural knowledge. Special chambers were dedicated to preserving the history and traditions of underwater civilizations. These archives contained detailed records of religious practices, cultural developments, and the evolution of underwater spiritual life. Community gatherings in underwater temples required careful planning and coordination. How did large groups safely gather for religious ceremonies? Special gathering halls were equipped with advanced life support systems and emergency protocols to ensure the safety of worshippers during extended ceremonies. The influence of marine life on religious practices cannot be overlooked. Many underwater spiritual traditions incorporated elements from the surrounding marine ecosystem. Sacred marine creatures were often featured in religious artwork and ceremonies, reflecting the deep connection between underwater communities and their environment. Seasonal celebrations in underwater temples were synchronized with marine biological cycles. Communities would gather to celebrate events like coral spawning or the migration of sacred marine species. These celebrations helped maintain a strong connection to the natural rhythms of ocean life. The architectural design of underwater temples often included features that worked in harmony with marine life. Some temples incorporated living coral as part of their structure, creating a dynamic, growing spiritual space that literally lived and breathed with the ocean. The Temple of the Deep also played a crucial role in maintaining connections between different underwater cities. Religious festivals and ceremonies often brought together communities from various underwater settlements, strengthening cultural bonds and facilitating the exchange of spiritual knowledge. What impact did these underwater temples have on the development of aquatic civilization? They served as anchors for community life, providing stability and continuity in the challenging underwater environment. The temples were more than just religious spaces, they were the heart of underwater cultural identity. The legacy of these underwater temples continues to fascinate us. Their innovative design solutions and adaptation of spiritual practices to an aquatic environment demonstrate the remarkable ability of human civilization to maintain cultural traditions while adapting to extreme conditions. Through understanding the Temple of the Deep, we gain valuable insights into how underwater communities maintained their spiritual and cultural identity while adapting to life beneath the waves. These sacred spaces stand as a testament to the resilience and creativity of underwater civilization, showing how spiritual practices can evolve and thrive in even the most challenging environments. Have you ever wondered how ancient civilizations recorded their stories beneath the waves? How did underwater societies preserve their knowledge, and what secrets lie in the depths of their sunken archives? Let's dive into the fascinating world of underwater documentation and the remarkable discoveries that reveal how aquatic civilizations maintained their written legacy. The preservation of documents underwater presents unique challenges that land-based archives never faced. Unlike traditional libraries, underwater archives required special techniques and materials to protect written knowledge from water damage and marine elements. Archaeological evidence has revealed several ingenious methods that ancient underwater societies developed to overcome these challenges. One of the most significant discoveries in underwater documentation was the use of water-resistant materials. Ancient underwater civilizations didn't use paper as we know it today. Instead, they developed specialized writing surfaces made from treated marine materials. These included processed and cured seaweed sheets, specially treated fish skins, and even thin, polished plates made from mother-of-pearl. These materials proved remarkably durable in underwater conditions, with some specimens dating back thousands of years. The writing systems themselves were equally fascinating. Rather than using traditional inks that would dissolve in water, underwater societies developed permanent etching techniques and used natural dyes extracted from marine organisms. These pigments were chemically stable in water and often contained minerals that actually became more permanent when exposed to underwater conditions. Some of the most well-preserved examples show text created using a paste made from ground coral and natural adhesives, which hardened into permanent raised characters. But how did they organize these underwater libraries? Archaeological evidence shows that underwater archives were typically housed in specially designed structures that protected documents from strong currents and marine life. These buildings often featured intricate drainage systems and were constructed with natural water flow patterns in mind. The archives were typically built into cave systems or rock formations, using natural geological features to their advantage. One of the most remarkable aspects of underwater documentation was the development of classification systems. Just as modern libraries use the Dewey Decimal System, underwater archives had their own organizational methods. Documents were often arranged in concentric circles, with the most important texts placed in the center of the archive. This radial arrangement made it easier for scholars to navigate the collection while swimming and allowed for better water circulation around the documents. The content of these preserved documents provides invaluable insights into ancient underwater societies. What kinds of information did they consider important enough to preserve? Records show a wide range of subjects, including 1. Agricultural techniques for underwater farming. 2. Marine engineering principles. 3. Navigation maps and current patterns. 4. Genealogical records of important families. 5. Religious texts and ceremonial procedures. 6. Scientific observations of marine life. 7. Trade agreements with surface dwellers. 8. Medical knowledge specific to underwater living. The discovery of these archives has revolutionized our understanding of underwater civilizations. For instance, we now know that they maintained complex diplomatic relationships with surface communities thanks to preserved treaties and trade agreements. These documents also reveal sophisticated scientific knowledge, including detailed studies of ocean currents and marine ecosystems that remain relevant today. Preservation techniques varied by region and era. In colder waters, archives often utilized natural ice formations for preservation, while in tropical regions, documents were stored in specialized chambers treated with natural antibiotic compounds derived from marine organisms. These compounds prevented the growth of harmful bacteria and algae that could damage the documents. The role of archivists in underwater societies was highly respected. These specialists underwent years of training to learn preservation techniques and document handling. They were responsible not only for maintaining the archives, but also for copying deteriorating documents onto new materials. This continuous process of documentation renewal ensured the survival of knowledge across generations. Translation of underwater documents presents unique challenges for modern researchers. Many underwater writing systems used symbols and patterns that mimicked natural marine formations, making them difficult to distinguish from natural markings. However, breakthrough discoveries of bilingual texts, similar to the Rosetta Stone, have helped scholars decode these ancient writing systems. The technology used in underwater documentation was remarkably advanced for its time. Archaeological evidence suggests the use of specialized tools for etching and writing, including instruments made from modified shell and bone materials. Some archives even show evidence of early forms of waterproof sealants used to protect particularly valuable documents. Modern marine archaeologists continue to discover new underwater archives, each providing fresh insights into these fascinating civilizations. These discoveries raise important questions about preservation techniques we might adapt for modern use. How can we learn from these ancient methods to better protect our own digital and physical archives from water damage? The study of underwater archives remains an active field of research, with new technologies enabling better exploration and documentation of these sites. Each discovery adds another piece to our understanding of how ancient underwater societies managed to preserve their knowledge and culture against the challenging conditions of their aquatic environment. As we continue to explore the depths of our oceans, what other documentary treasures might we find? What additional insights might these ancient underwater archives provide about sustainable living in marine environments? The answers lie waiting in the depths, preserved in these remarkable underwater libraries that have survived the test of time and tides. Throughout Earth's history, there have been numerous instances where entire cities and landmasses have disappeared beneath the waves. Today, we'll explore the fascinating geological processes that lead to these dramatic submergences and understand why some of our coastal cities might face similar fates in the future. Let's start with the basic concept of subsidence, the gradual sinking of land due to various geological factors. Have you ever wondered why some ancient port cities are now completely underwater? The answer lies in the complex interaction between natural forces that have been at work for millions of years. One of the primary causes of land submergence is tectonic activity. Our planet's crust is constantly moving, shifting, and reorganizing itself through plate tectonics. When tectonic plates collide, one plate can be forced beneath another in a process called subduction. This doesn't just happen suddenly, it's a gradual process that can take thousands or even millions of years. Cities built on or near these active zones can slowly sink as the ground beneath them descends. But what about areas that aren't on plate boundaries? Well, another significant factor is isostatic adjustment. Think of the Earth's crust as floating on the denser mantle below, much like ice cubes float in water. When weight is added to or removed from the crust, such as during ice ages, the land responds by sinking or rising accordingly. This process continues long after the initial weight change, leading to gradual submergence or emergence of coastal areas. Groundwater extraction plays a crucial role in modern-day submergence. As growing cities pump out underground water for their needs, the land above can compact and sink, a process called aquifer system compaction. Mexico City, for instance, is sinking at an alarming rate of up to 50 centimeters per year in some areas due to excessive groundwater pumping. Can you imagine the implications for a city of over 9 million people? Sediment compaction is another key factor. When cities are built on river deltas or soft sediments, the weight of buildings and infrastructure causes the ground to compact over time. Venice, Italy, is a prime example of this phenomenon. The city has sunk about 24 centimeters over the past century, partly due to the weight of its historic buildings compressing the marshy ground beneath. Climate change and sea level rise compound these problems. As global temperatures increase, thermal expansion of the oceans and melting ice caps contribute to rising sea levels. This makes coastal areas more vulnerable to submergence, especially when combined with natural geological processes. Did you know that some Pacific islands are already disappearing beneath the waves due to this combination of factors? Historical examples of submerged cities provide fascinating insights into this phenomenon. The ancient Egyptian cities of Phonis Heracleion and Canopus remained hidden beneath the Mediterranean Sea for over 1,000 years before their recent discovery. These cities sank due to a combination of rising sea levels, ground liquefaction, and tectonic activity. Looking at more recent events, the Japanese village of Toyooka provides a striking example of rapid submergence. During a 1927 earthquake, parts of the village suddenly sank by several meters due to soil liquefaction, a process where waterlogged sediments temporarily lose their strength during seismic activity. The science of predicting future submergence has become increasingly sophisticated. Geologists use various tools and techniques, including satellite measurements, GPS monitoring, and geological surveys to track land movement and predict vulnerable areas. This information is crucial for urban planning and disaster preparedness. What can we do to prevent or mitigate the effects of submergence? Engineering solutions like seawalls, land reclamation, and improved drainage systems can help protect vulnerable areas. However, these are often temporary solutions to a long-term problem. Some cities are already planning for managed retreat, the strategic relocation of communities away from high-risk areas. Understanding the Great Submergence isn't just about looking at the past or present, it's about preparing for the future. As our climate continues to change and urban development increases, more cities may face the threat of submergence. The key lies in understanding these geological processes and taking proactive measures to protect our coastal communities. The story of the Great Submergence continues to unfold, reminding us of the dynamic nature of our planet and the need to adapt to its ever-changing conditions. As we face these challenges, the question remains: how will our coastal cities evolve to survive in a world where land and sea boundaries are increasingly fluid? As we explore how ancient societies adapted to rising water levels, we must first understand the remarkable ingenuity and resilience of our ancestors. How did they transform their way of life when faced with the challenges of an increasingly aquatic world? Let's dive into this fascinating chapter of human history. Following the Great Submergence, when vast coastal areas disappeared beneath rising waters, human communities faced an unprecedented challenge. Rather than abandoning their ancestral lands entirely, many societies developed innovative solutions to continue living in these transformed environments. These adaptations occurred gradually over several generations, allowing communities to evolve their survival strategies. One of the most significant adaptations was the development of raised settlements. Archaeological evidence reveals that coastal communities in various parts of the world began constructing elevated platforms using local materials like wood, stone, and compacted earth. These structures, known as artificial dwelling mounds or terpts, became particularly common in regions like the North Sea coast. Some of these mounds grew to heights of up to 15 meters, protecting entire villages from regular flooding while maintaining access to vital marine resources. But how did these communities manage their daily activities in such waterlogged conditions? The answer lies in their innovative transportation solutions. Traditional land-based transportation gave way to sophisticated watercraft systems. Archaeological findings show the development of specialized boats designed for different purposes: shallow draft vessels for navigating flooded streets, larger trading vessels for maintaining economic connections, and small, agile craft for fishing and gathering resources. The transformation of agriculture presents another fascinating aspect of aquatic adaptation. As traditional farming became impossible in submerged areas, communities developed floating gardens and artificial islands. These structures, similar to the chenampas of ancient Mesoamerica, were created by layering organic matter and soil over reed foundations. These floating fields not only provided essential food production, but also helped maintain soil fertility through the constant presence of nutrient-rich water. Housing architecture underwent significant changes during this period. Traditional ground-level dwellings were replaced by structures built on stilts, creating what we now call pile dwellings. These houses, elevated above water level, were connected by raised walkways and bridges, forming entire communities that existed in harmony with their watery environment. Evidence of such adaptations can be found in archaeological sites worldwide, from the alpine regions of Europe to Southeast Asian coastal areas. The adaptation to aquatic environments also led to the development of new fishing and hunting techniques. Communities refined their methods for harvesting marine resources, creating sophisticated fish traps, developing new types of nets, and establishing sustainable fishing practices. These innovations weren't just about survival, they represented a fundamental shift in how these societies viewed their relationship with water. What about waste management and freshwater access? Archaeological evidence shows the development of complex systems for managing these essential aspects of daily life. Communities created elevated freshwater storage systems, developed methods for rainwater collection, and established sophisticated waste management practices that prevented water contamination. The social structure of these communities also evolved to meet new challenges. New roles emerged: specialized boat builders, water navigation experts, and engineers who maintained the raised structures became essential members of society. The organization of labor changed to accommodate the unique demands of living in an aquatic environment, leading to more cooperative social systems. Trade networks adapted and evolved as well. Water routes became primary transportation corridors, leading to the development of new trading patterns and economic relationships. Communities that successfully adapted to aquatic living often became important trading hubs, connecting inland areas with maritime routes. Perhaps most remarkably, these adaptations led to the development of new cultural practices and beliefs. Archaeological evidence suggests changes in religious practices, with many communities developing water-centered spiritual traditions. Art and craft from these periods often feature aquatic themes, reflecting the central role of water in daily life. The legacy of these aquatic adaptations continues to influence modern coastal engineering and urban planning. Many of the solutions developed by ancient societies provide valuable insights for contemporary communities facing similar challenges due to climate change and rising sea levels. What can we learn from these ancient adaptations? The evidence shows that human societies are remarkably adaptable when faced with environmental challenges. Rather than viewing water as an insurmountable obstacle, these communities found ways to integrate it into their daily lives, developing solutions that were both practical and sustainable. This period of aquatic adaptation demonstrates the incredible resilience and creativity of human societies. By studying these historical examples, we gain valuable insights into how communities can successfully adapt to dramatic environmental changes while maintaining their cultural identity and social cohesion. Have you ever wondered how ancient underwater civilizations managed to not just survive, but thrive beneath the waves? The development of maritime technologies played a crucial role in their adaptation and eventual mastery of aquatic environments. Let's explore these fascinating technological achievements that transformed human civilization beneath the seas. One of the most fundamental maritime technologies was the development of underwater breathing apparatus. Unlike our modern scuba gear, ancient underwater societies created complex systems using naturally available materials. They engineered elaborate networks of hollow reeds and treated animal bladders to create primitive but effective breathing devices. These systems allowed them to stay submerged for extended periods, enabling activities like underwater construction and resource gathering. The challenge of underwater communication led to remarkable innovations. Without the ability to speak normally underwater, these civilizations developed sophisticated systems of sound-based communication. They created underwater drums and resonating chambers that could transmit messages across significant distances. These acoustic devices utilized the superior sound-conducting properties of water, allowing messages to travel faster and farther than they would in air. Some communities even developed a complex language of clicks and whistles, similar to those used by marine mammals. Underwater construction techniques represented another significant technological achievement. How did they manage to build stable structures under such challenging conditions? The answer lies in their mastery of underwater cementing materials. They discovered and refined natural hydraulic cements that could set and harden underwater, similar to modern Portland cement, but derived from volcanic materials and organic compounds. These materials were crucial for creating permanent underwater settlements. Transportation beneath the waves required innovative solutions. Early underwater societies developed various propulsion systems using principles of hydraulic pressure and marine animal locomotion. They created mechanical fins and flippers that mimicked the movement of sea creatures, allowing for efficient underwater movement. Some communities even domesticated certain marine species, training them to assist with transportation and heavy lifting tasks. Light was another critical challenge that needed technological solutions. In the darker depths, these civilizations developed bioluminescent lighting systems. They cultivated and selectively bred naturally luminescent organisms, creating sustainable light sources. These living lights were integrated into their architecture and portable devices, providing illumination without the need for fire-based lighting that wouldn't work underwater. Food preservation and storage technologies were essential for underwater living. Special containers were developed that could maintain food freshness while submerged. These societies created pressure-resistant storage vessels using natural materials like treated animal skins and sealed ceramic containers. They also developed methods of underwater food cultivation, creating the first submarine agricultural systems. Tool-making underwent a complete revolution to adapt to underwater conditions. Traditional materials like wood and metal had to be specially treated to prevent deterioration in saltwater. They developed corrosion-resistant alloys and waterproof coatings derived from marine organisms. These innovations led to the creation of specialized underwater tools for construction, farming, and daily life activities. Energy generation and utilization represented another technological breakthrough. These societies learned to harness underwater currents and thermal vents for power. They created mechanical systems that could convert water movement into usable energy, powering various devices and mechanisms in their underwater settlements. The development of underwater navigation systems was crucial for these maritime civilizations. They created sophisticated methods of underwater wayfinding using natural features, current patterns, and even the behavior of marine life. Some communities developed early forms of underwater maps and direction-finding devices that worked without reliance on celestial navigation, which wasn't visible from beneath the waves. Protection against dangerous marine life required technological solutions as well. These societies developed various defensive systems, from physical barriers to chemical deterrents derived from marine organisms. They learned to create protective enclosures that could keep dangerous predators at bay while allowing safe passage for community members. Waste management and environmental protection technologies were also developed. These underwater civilizations created systems for processing and recycling waste materials without contaminating their living environment. They understood the delicate balance of marine ecosystems and developed technologies to maintain environmental stability. The legacy of these maritime technologies continues to influence modern underwater engineering and exploration. Many of the principles discovered by these ancient underwater societies form the foundation of contemporary marine technology. Their innovations in underwater construction, communication, and resource management continue to provide valuable insights for modern applications. What's particularly remarkable about these maritime technologies is how they evolved through necessity and innovation. Each challenge presented by underwater living was met with creative solutions that often surpassed their above-water counterparts in sophistication. These developments demonstrate human ingenuity at its finest, showing how adversity can drive technological advancement. As we continue to explore and utilize underwater environments today, understanding these historical maritime technologies provides valuable lessons and inspiration. The solutions developed by these ancient underwater civilizations remind us that human adaptation and technological innovation know no bounds, even in the most challenging environments. Deep beneath the ocean's surface lies a world of extraordinary treasures, each telling a unique story of underwater civilizations and their remarkable achievements. These precious artifacts, preserved in the depths of the abyss, hold immense significance in understanding the rich cultural heritage and technological advancement of aquatic societies. Let's begin by exploring the most significant treasures found in underwater cities. The crystalline archives, vast collections of knowledge stored in specialized pressure-resistant crystal formations, serve as the primary repositories of historical records. These crystals, naturally formed through centuries of mineral deposits, have been expertly carved and encoded with information using advanced sonic resonance techniques. But have you ever wondered how these underwater civilizations managed to preserve their history without traditional paper or digital methods? The answer lies in their ingenious use of bioluminescent coral matrices. These living storage systems contain billions of microscopic organisms that can retain and display information through patterns of light emission. When activated by specific frequencies of sound waves, these coral matrices illuminate in sequences that reveal ancient texts, maps, and scientific data. This technology has proven far more durable than any surface-dwelling civilization's storage methods, withstanding extreme pressures and surviving for millennia. Among the most valued treasures are the pressure pearls, unique spherical formations created in the deepest trenches where immense pressure transforms organic matter into iridescent gems. Unlike surface pearls, these specimens contain concentrated deposits of rare earth elements, making them not just beautiful, but also technically valuable for powering advanced underwater systems. Scientists have documented over 300 distinct varieties of pressure pearls, each with its own specific composition and properties. The abyssal forges represent another category of precious artifacts. These ancient manufacturing centers utilize geothermal vents to create tools and structures from materials found only in deep ocean environments. The most remarkable aspect of these forges is their ability to manipulate metals at extreme depths without the need for traditional heating methods. How did they achieve this? The answer lies in their use of specialized bacteria that can separate and reform molecular bonds in metals, allowing for cold forging processes that were previously thought impossible. Architectural treasures also abound in underwater cities. The famous coral cathedrals, massive structures grown rather than built, showcase the perfect harmony between biological engineering and architectural design. These living buildings continue to grow and adapt to their environment, with some specimens estimated to be over 5,000 years old. The secret to their longevity lies in the symbiotic relationship between engineered coral species and specialized algae that provide structural reinforcement. The treasury of sonic artifacts contains collections of tools and instruments designed to harness and manipulate sound waves. In an environment where visual communication is limited, these devices played a crucial role in underwater civilization development. The most notable among these is the harmonic resonator, a device capable of generating precise frequencies that can be used for everything from communication to construction. Biological treasures form another crucial category. The gene banks of the deep preserve countless specimens of marine life, many of which are now extinct in the wild. These carefully maintained repositories contain DNA samples from over 50,000 species, providing invaluable information about ocean biodiversity and evolution. But what makes these gene banks truly remarkable is their self-maintaining nature, using advanced biotechnology to automatically repair and replicate genetic material. The mineral gardens represent some of the most beautiful treasures of the abyss. These carefully cultivated fields of crystalline formations contain rare earth elements and precious metals in their purest forms. Unlike surface mining operations, these gardens use biological processes to extract and purify minerals without damaging the surrounding ecosystem. The techniques developed here have revolutionized our understanding of sustainable resource management. One of the most mysterious treasures is the collection of time capsules of the deep. These sealed containers, found scattered throughout underwater cities, contain perfectly preserved specimens of daily life from various periods. The preservation quality is so exceptional that organic materials show virtually no degradation, thanks to the unique combination of pressure, temperature, and chemical conditions at these depths. The significance of these treasures extends beyond their historical value. They provide crucial insights into sustainable living practices, efficient resource management, and harmonious cooperation with natural systems. Many of the technologies and methods discovered in these underwater artifacts have practical applications for surface civilization challenges. The documentation system used to catalog these treasures is itself a remarkable achievement. The Abyssal Registry, maintained by specialized archivists, uses a three-dimensional mapping system that records not just the physical characteristics of artifacts, but also their ecological and cultural context. This holistic approach to preservation ensures that future generations will understand not just what these treasures are, but why they were important to underwater civilizations. As we continue to explore and study these underwater treasures, new discoveries regularly emerge that challenge our understanding of ancient technologies and cultural practices. The abyss holds countless more secrets waiting to be uncovered, each promising to add another piece to the fascinating puzzle of underwater civilization development. These treasures serve as a reminder of the incredible adaptability and ingenuity of life in extreme environments. They demonstrate how necessity and innovation can lead to solutions that might seem impossible by conventional standards. What other secrets might still lie hidden in the depths, waiting to be discovered? The exploration continues, and with each new finding, our appreciation for these underwater wonders grows deeper. Have you ever wondered how ancient underwater civilizations managed to sustain themselves? The discovery of submarine agriculture practices has revolutionized our understanding of how underwater communities thrived and produced food in seemingly impossible conditions. Let's dive deep into the fascinating world of underwater farming and food production systems that have been uncovered by marine archaeologists and researchers. Archaeological evidence has revealed sophisticated underwater farming methods that date back thousands of years. These findings challenge our previous assumptions about the capabilities of ancient civilizations and their ability to adapt to underwater environments. What's particularly interesting is how these communities developed innovative solutions to grow food in conditions that we traditionally consider hostile to agriculture. One of the most significant discoveries has been the presence of hydroponic-like systems in underwater ruins. These ancient systems show remarkable similarities to modern hydroponic farming techniques, where plants are grown without soil, using mineral nutrient solutions in water. Archaeological records indicate that underwater communities utilized natural mineral-rich water currents to nourish their crops, creating what we might call the world's first submarine greenhouses. The evidence of underwater food production isn't limited to plant cultivation. Researchers have found extensive networks of what appear to be fish farming enclosures. These structures, often carved into natural rock formations or built using coral-based materials, served as ancient aquaculture systems. These early fish farms demonstrated remarkable efficiency in maintaining sustainable food sources for underwater populations. But how did they manage to create suitable growing conditions in such challenging environments? The answer lies in their ingenious use of natural light and temperature gradients. Archaeological findings show that underwater farmers took advantage of thermoclines, layers of water at different temperatures, to create optimal growing conditions for various crops. They constructed terraced gardens that maximized exposure to filtered sunlight while protecting plants from harmful deep water pressures. The discovery of specialized tools and equipment provides further insight into submarine agricultural practices. These include modified harvesting implements, specially designed containers for plant cultivation, and sophisticated irrigation systems that utilized natural water currents. What's particularly fascinating is how these tools were adapted to function effectively underwater, showing remarkable engineering capabilities. Evidence of seaweed farming has been particularly abundant in underwater archaeological sites. These ancient communities recognized the nutritional value of various seaweed species and developed methods to cultivate them systematically. The farming techniques they employed are surprisingly similar to modern seaweed farming methods, suggesting that these ancient practices were highly advanced for their time. Researchers have also uncovered evidence of symbiotic farming practices where different species were grown together to create sustainable ecosystems. This early form of polyculture demonstrates a sophisticated understanding of marine ecology and sustainable food production. For instance, findings show that certain fish species were deliberately introduced to help maintain the health of underwater plant crops. The preservation of these agricultural sites has been remarkable, thanks to the unique conditions of underwater environments. Sediment layers have protected many of these ancient farms, allowing archaeologists to study their structure and organization in detail. What's particularly valuable is how these preserved sites provide insights into the evolution of underwater farming techniques over time. The scale of these underwater farming operations is also noteworthy. Archaeological evidence suggests that some underwater communities maintained extensive agricultural networks that could feed thousands of people. These findings challenge our understanding of ancient population densities and community organization in underwater settlements. The discovery of storage facilities near these farming sites provides additional information about food preservation methods. These structures show how underwater communities developed sophisticated techniques to store and preserve their harvests, protecting them from water damage and marine organisms. The impact of these discoveries extends beyond historical interest. Modern researchers are studying these ancient techniques to develop sustainable underwater farming methods for future use. Could these ancient practices hold the key to addressing modern food security challenges as sea levels rise? The evidence of underwater farming also provides insights into ancient trade networks. Some underwater communities appear to have specialized in certain crops or farming techniques, suggesting the existence of complex trade relationships between different underwater settlements. Perhaps most importantly, these discoveries help us understand how ancient civilizations adapted to changing environmental conditions. As sea levels rose and coastal areas became submerged, communities didn't simply abandon their homes, they adapted and developed innovative solutions to continue food production underwater. The study of submarine agriculture continues to yield new insights. Each discovery adds to our understanding of how ancient underwater communities sustained themselves and managed to thrive in what we would consider extreme conditions. What other secrets might these underwater farms still hold? As technology advances and we gain access to deeper and more remote underwater sites, we may uncover even more remarkable evidence of ancient submarine agricultural practices. These findings not only illuminate our past, but also offer valuable lessons for our future. As we face modern challenges related to climate change and rising sea levels, the innovative solutions developed by ancient underwater farmers might provide inspiration for developing sustainable food production methods in a changing world. In our continuing exploration of the underwater discoveries, we encounter one of the most remarkable architectural achievements ever documented: the crystal chambers. What makes these structures so extraordinary, and how did ancient civilizations manage to incorporate natural sea formations into their architectural designs? Let's dive deep into this fascinating aspect of underwater archaeology. The crystal chambers represent a perfect fusion of natural marine geology and intentional human engineering. These structures, discovered alongside the underwater agricultural sites, showcase an advanced understanding of marine architecture that challenges our current perceptions of ancient technological capabilities. At their core, the crystal chambers are a network of interconnected cavities formed within naturally occurring sea caves. What makes them unique is the deliberate modification and enhancement of these natural formations. The primary building material appears to be crystalline formations that are indigenous to deep-sea environments. These aren't just ordinary crystals, they're massive geological structures that have been carefully incorporated into habitable spaces. The fundamental composition of these chambers relies on several types of marine minerals. 1. Aragonite crystals, naturally formed calcium carbonate structures. 2. Deep-sea quartz formations. 3. Mineral deposits from hydrothermal vents. 4. Crystallized salt structures. But how did the ancient builders utilize these materials? Evidence suggests they employed a sophisticated understanding of marine geology. The chambers show signs of careful excavation around natural crystal formations, with supporting structures that work in harmony with the natural growth patterns of these minerals. Instead of quarrying and moving massive crystal formations, the ancient builders appear to have encouraged and guided crystal growth in specific directions. One of the most intriguing aspects is the chamber's structural integrity. Despite being subjected to intense underwater pressure and centuries of marine activity, many of these structures remain largely intact. This durability stems from the builders' ingenious use of natural reinforcement techniques. They position supporting structures along natural stress lines within the crystal formations, creating a self-reinforcing architectural system that has withstood the test of time. The layout of the crystal chambers reveals a complex understanding of marine acoustics. The crystalline walls create unique sound reflection patterns underwater, suggesting these spaces might have served specific acoustic purposes. Could these chambers have been used for communication? Or did they serve some other acoustic function we haven't yet understood? The chambers exhibit several distinct architectural features. 1. Geometric precision. Despite working with natural formations, the modified sections show remarkable mathematical accuracy in their angles and proportions. 2. Light amplification. The crystal structures appear to have been positioned to maximize the penetration and distribution of what little natural light reaches these depths. 3. Pressure management. The design includes what appears to be an early form of pressure regulation system using the natural properties of the crystal formations to maintain structural stability. 4. Integration with marine life. Evidence suggests the builders incorporated living marine organisms into their design, creating a symbiotic relationship between the structure and its environment. The technological implications of these discoveries are profound. How did ancient builders achieve such precise modifications underwater? What tools and techniques were at their disposal? The evidence points to a level of technological sophistication that forces us to reconsider our understanding of ancient capabilities. Analysis of tool marks and construction patterns reveals several interesting facts. The crystal surfaces show signs of precise cutting and shaping. There are regular patterns suggesting systematic construction methods. Evidence of heat treatment on certain crystal surfaces. Presence of artificial binding materials between crystal formations. The purpose of these chambers remains a subject of intense debate among researchers. Their location near underwater agricultural sites suggests they might have served practical functions related to food storage or processing. However, the elaborate nature of their construction and their acoustic properties hint at possible ceremonial or communal uses. The crystal chambers also provide valuable insights into ancient engineering principles. 1. Understanding of material properties under extreme pressure. 2. Knowledge of crystal growth and formation. 3. Sophisticated acoustic engineering. 4. Advanced underwater construction techniques. Perhaps most remarkably, these chambers appear to have been designed with environmental sustainability in mind. The structures work in harmony with natural marine processes rather than against them. This suggests an advanced understanding of marine ecology that we're only now beginning to fully appreciate. The discovery of the crystal chambers raises important questions about ancient technological capabilities. How did they achieve such precise underwater construction? What was their understanding of marine geology? How did they develop their construction techniques? What were these chambers used for? These questions continue to drive ongoing research and investigation. Each new discovery within the crystal chambers provides additional pieces to this fascinating archaeological puzzle, challenging our assumptions about ancient civilizations' technological capabilities and their relationship with the marine environment. The crystal chambers stand as a testament to human ingenuity and our ancestors' ability to work in harmony with natural formations. They represent not just architectural achievement, but a sophisticated understanding of marine geology, acoustics, and environmental sustainability that continues to impress modern researchers. As we continue to study these remarkable structures, we're not just learning about ancient construction techniques, we're gaining insights into sustainable architectural practices that could inform modern marine construction projects. The crystal chambers remind us that sometimes the most advanced solutions involve working with nature rather than attempting to dominate it. Throughout human history, stories of mysterious underwater cities and civilizations have captured our imagination. These legends, passed down through generations, often blur the line between myth and reality. Let's explore some of the most fascinating accounts of underwater cities and the historical context behind these captivating tales. Have you ever wondered why so many cultures share similar stories about lost underwater cities? The answer lies in our ancient connection to the seas and the real geological events that shaped our planet. One of the most famous underwater city legends is Atlantis, first mentioned by Plato in his dialogues Timaeus and Critias. But did you know that Atlantis is just one of many underwater city legends that exist across different cultures? In Japanese folklore, there's the legend of Yamatai, an underwater palace called Ryugujo, home to the dragon god of the sea. This palace was said to be made of red and white coral, with fish serving as its guardians. The story has been documented in historical texts dating back to the 8th century, showing how deeply these underwater myths are embedded in cultural history. Moving to the Indian Ocean, we find the legend of Dwarka, an ancient city that, according to Hindu traditions, was built by Lord Krishna himself. What makes this legend particularly interesting is that archaeological evidence has revealed underwater structures off the coast of modern-day Dwarka, India. While these findings don't prove the mythological account, they demonstrate how legends often have some basis in historical fact. The Caribbean holds its own fascinating underwater city legends. The indigenous peoples of the region passed down stories of entire communities that were swallowed by the sea. These tales gained new significance when researchers discovered evidence of prehistoric settlements that were indeed submerged due to rising sea levels after the last ice age. But what drives these persistent legends of underwater cities? The answer lies in both historical and geological factors. During the last ice age, sea levels were significantly lower, and many coastal settlements were eventually submerged as the waters rose. This real phenomenon likely contributed to the creation and persistence of underwater city myths across different cultures. Chinese legends speak of the lion city of Quandao Lake, which, unlike many other underwater city legends, has a verified historical basis. The city was intentionally flooded in 1959 to create a reservoir, and its well-preserved underwater ruins continue to fascinate divers and researchers today. The Mediterranean Sea holds numerous accounts of submerged cities. The ancient Egyptian city of Heracleion remained a legend until its rediscovery in 2000. This discovery proves that some legends are based on actual historical sites that were lost to the seas due to natural disasters or geological changes. Port Royal in Jamaica presents another fascinating case. Once known as the wickedest city on Earth, it was partially submerged following a devastating earthquake in 1692. The event was so impactful that it spawned numerous legends and cautionary tales about divine punishment, demonstrating how natural disasters can give rise to enduring myths. These legends often share common elements. They typically involve advanced civilizations, divine intervention, and some form of catastrophic event leading to their submergence. Why do you think these patterns appear across different cultures and time periods? The answer might lie in our universal human experiences with floods, earthquakes, and other natural disasters. The scientific community has found that many of these legends serve as valuable historical records. They often contain information about ancient coastlines, geological events, and climate changes that can be verified through modern research methods. For instance, stories of submerged cities around the Mediterranean have helped archaeologists locate actual underwater ruins. Modern technology has revolutionized our ability to investigate these underwater legends. Sonar mapping, underwater archaeology, and advanced diving equipment have allowed us to discover numerous submerged settlements that were once thought to be purely mythical. This raises an intriguing question: how many more legendary underwater cities are waiting to be discovered? The oral histories of indigenous peoples have proven particularly valuable in this regard. Aboriginal Australian Dreamtime stories, for example, have helped researchers locate submerged archaeological sites on the continental shelf, demonstrating the historical value of these oral traditions. These legends continue to influence modern culture and scientific research. They inspire marine archaeologists to explore new sites and encourage the preservation of underwater cultural heritage. The United Nations Educational, Scientific and Cultural Organization, UNESCO, now recognizes numerous submerged archaeological sites as important cultural heritage locations. Understanding these legends helps us appreciate how our ancestors interpreted and recorded major geological and historical events. They serve as a reminder that myths often contain kernels of truth, preserved through oral traditions and cultural memory. As we continue to explore our oceans with advanced technology, we may find that more of these legends have factual foundations than we previously thought. The study of underwater city legends also provides valuable insights into human adaptation to climate change and rising sea levels. Many of these stories record how ancient communities responded to changing coastlines and environmental conditions, offering potential lessons for our modern challenges with rising sea levels. The fascinating world of underwater metalworking has remained one of the most remarkable achievements in human history. Have you ever wondered how ancient civilizations managed to forge metals beneath the waves? Let's dive into the intriguing realm of marine metallurgy and discover how underwater settlements mastered this crucial technology. Marine metallurgy began as a necessity for underwater communities who needed to develop specialized techniques for working with metals in submerged conditions. The fundamental challenge was clear: how could they maintain the high temperatures required for metalworking while surrounded by water? The answer lies in their ingenious solutions and adaptations of traditional metallurgical practices. The first breakthrough in marine metallurgy came with the development of underwater forges. These structures were essentially sealed chambers where metalworkers could maintain the necessary heat and pressure for working with various metals. The forges were typically constructed using a combination of heat-resistant materials and innovative ventilation systems that prevented water infiltration while allowing for proper air circulation. One of the most significant aspects of marine metallurgy was the use of geothermal vents. Underwater settlements often positioned their metalworking facilities near these natural heat sources, taking advantage of the extreme temperatures they provided. This natural energy source eliminated the need for conventional fuel and helped overcome the challenges of maintaining high temperatures underwater. The types of metals worked in these underwater forges were carefully chosen based on their properties and resistance to corrosion. Copper and its alloys, particularly bronze, became the preferred materials due to their relatively low melting points and excellent resistance to saltwater corrosion. Gold and silver, being noble metals, were also extensively used in marine metallurgy due to their natural resistance to oxidation. But how did they prevent the molten metal from cooling too quickly in the underwater environment? The answer lies in the development of specialized insulation techniques. Marine metalworkers created multiple layers of protection around their work areas using materials like volcanic rock and ceramic compounds that could maintain stable temperatures despite the surrounding water pressure. The tools used in marine metallurgy were equally innovative. Traditional blacksmith's tools were modified to function in underwater conditions, with longer handles and specialized grips that allowed for precise control, even in the aqueous environment. These tools were often coated with protective materials to prevent corrosion and maintain their durability. One of the most remarkable aspects of marine metallurgy was the development of pressure-resistant forging techniques. The high pressure at depth posed unique challenges, but metalworkers learned to use this to their advantage. They developed methods to utilize the pressure for compressing and shaping metals, creating stronger and more durable products than their surface-dwelling counterparts. The applications of marine metallurgy were vast and varied. From creating tools and weapons to constructing infrastructure and decorative elements, underwater metalworking became essential to the survival and prosperity of underwater settlements. The techniques developed were used to create everything from simple fasteners to complex mechanical systems designed to function in underwater environments. Knowledge transfer played a crucial role in the advancement of marine metallurgy. Underwater communities developed sophisticated apprenticeship systems to pass down their metalworking knowledge from generation to generation. This ensured the continuation and improvement of their techniques over time. The influence of marine metallurgy extended beyond underwater settlements. Many of the techniques developed for underwater metalworking were later adapted for use in surface-based metallurgy, particularly in environments where traditional forging methods were impractical or impossible. Safety measures in marine metallurgy were paramount. Workers developed elaborate systems to prevent accidents and protect themselves from the dangers of working with hot metals underwater. These included specialized protective gear, emergency protocols, and carefully designed workspace layouts that minimized risks. The legacy of marine metallurgy continues to influence modern underwater construction and engineering. Many of the principles developed by these ancient metalworkers are still applied today in underwater welding and metal fabrication, demonstrating the enduring value of their innovations. The economic impact of marine metallurgy cannot be understated. The ability to work with metals underwater opened up new possibilities for trade, construction, and technological advancement in underwater settlements. It created specialized roles and professions, contributing to the social and economic structure of these communities. As we look to the future, the principles of marine metallurgy remain relevant. Modern underwater construction and engineering continue to build upon these foundational techniques, adapting them for contemporary challenges and applications. The ingenuity of ancient marine metalworkers continues to inspire new generations of engineers and craftspeople. Understanding marine metallurgy helps us appreciate the remarkable achievements of underwater civilizations and their contributions to human technological advancement. It stands as a testament to human innovation and adaptability, showing how challenges can be transformed into opportunities for technological progress. Have you ever wondered how art thrives beneath the waves? As human civilization expanded into underwater habitats, a fascinating new form of artistic expression emerged, uniquely adapted to the aquatic environment. Let's explore how creativity flows in the depths of our oceans. Underwater art has evolved into a distinct discipline, incorporating the physical properties of water to create stunning visual and interactive experiences. The medium of water itself plays a crucial role in how these artistic works are perceived and experienced. Light behaves differently underwater, creating natural refractions and caustic patterns that artists have learned to harness in their creations. One of the most significant developments in aquatic artistry has been the use of bioluminescent organisms in artistic installations. Artists cultivate and arrange naturally glowing plankton, bacteria, and other marine organisms to create living light displays. These biological light shows are not only beautiful, but also entirely sustainable, as they rely on the natural properties of marine life. Sculpture has taken on new meaning in underwater environments. Traditional materials like bronze and steel interact with seawater in predictable ways, developing distinct patterns that artists incorporate into their work. The phenomenon of marine growth on sculptures has given rise to living sculptures, where artists deliberately create structures that serve as artificial reefs, combining aesthetic appeal with ecological function. Underwater murals utilize special pigments and sealants developed specifically for submerged environments. These materials resist degradation from saltwater and maintain their vibrancy for extended periods. Artists often work with marine-safe paints that pose no threat to aquatic ecosystems, demonstrating how artistic expression can coexist with environmental responsibility. Performance art has found a unique home underwater, with dancers and performers using the three-dimensional freedom of movement that water provides. Special underwater stages equipped with lighting systems and sound transmission technology enable audiences to experience these performances from within climate-controlled viewing areas or through high-definition video feeds. Sound art has become particularly significant in underwater settlements. Water's superior sound conduction properties allow for innovative acoustic installations. Artists create compositions that utilize the specific way sound travels underwater, often incorporating natural marine sounds into their work. Have you ever noticed how different music sounds when you're underwater? This principle has led to the development of specialized underwater concert venues and sound gardens. Digital art has adapted to underwater display systems, with holographic projections being especially effective in water. The natural refraction and reflection of light in water enhance these displays, creating immersive experiences that wouldn't be possible on land. Interactive installations use motion sensors and pressure detection to respond to viewers' movements through the water. Photography and videography have evolved to capture the unique qualities of underwater light and movement. Specialized cameras and lighting equipment have been developed to document both artistic performances and the natural beauty of marine environments. These tools have given rise to a new genre of underwater documentary art that bridges the gap between artistic expression and marine science. The influence of marine life on underwater art cannot be overstated. Artists draw inspiration from the forms and movements of sea creatures, creating kinetic sculptures that mimic the fluid motion of marine life. Some artists work directly with marine organisms, creating controlled environments where coral and other sea life grow in artistic patterns. Cultural expressions in underwater settlements often reflect the unique challenges and experiences of subsea living. Festivals and celebrations incorporate elements specific to underwater life, such as bioluminescent displays and underwater processions. These events help build community identity and maintain cultural connections in underwater settlements. Educational institutions dedicated to aquatic arts have emerged, teaching specialized techniques for creating and preserving art in underwater environments. These schools combine traditional artistic principles with marine science and engineering, preparing artists to work in this unique medium. Conservation plays a crucial role in underwater art. Many artists use their work to raise awareness about marine environmental issues, creating pieces that highlight the impact of pollution, climate change, and habitat destruction on ocean ecosystems. Can you think of a more powerful way to communicate environmental messages than through art that exists within the affected environment itself? The preservation of underwater artwork presents unique challenges. Conservators must consider factors such as water pressure, salinity, and marine growth when maintaining pieces. Special techniques have been developed to protect artwork from these elements while allowing it to remain accessible to viewers. The future of aquatic artistry continues to evolve with technological advances. New materials, tools, and techniques are constantly being developed, expanding the possibilities for artistic expression underwater. Virtual and augmented reality technologies are being integrated into underwater art experiences, allowing for even more immersive and interactive installations. As we look to the future of human expansion into marine environments, aquatic artistry stands as a testament to human creativity and adaptability. It demonstrates how art can not only survive, but thrive in new environments, creating beautiful and meaningful expressions of human culture beneath the waves. What new forms of underwater art will emerge as we continue to explore and inhabit the ocean depths? Throughout human history, few commodities have held as much importance as salt. The story of salt is not just about a mineral that makes our food taste better. It's a tale of empire building, trade routes that shaped civilizations, and a resource so valuable it was once used as currency. Let's explore the fascinating journey of the salt trade networks and how they influenced resource management across centuries. Have you ever wondered why the word salary comes from the Latin word for salt? In ancient Rome, soldiers were paid in salt, giving rise to the phrase worth their salt. This simple fact demonstrates just how crucial this mineral was to human civilization. But why was salt so incredibly valuable? Salt was essential for food preservation in a world without refrigeration. It allowed communities to store food for longer periods, travel greater distances with preserved supplies, and survive harsh winters. This preservation capability made salt one of the most traded commodities in history, leading to the establishment of extensive trade networks known as salt roads. The most famous of these routes was the Trans-Saharan salt trade. Imagine caravans of camels trudging across the scorching Sahara Desert, loaded with salt slabs from mines in the north, trading them for gold and other precious commodities from the great empires of West Africa. Cities like Timbuktu became wealthy trading hubs precisely because they controlled these vital salt routes. But the salt trade wasn't limited to Africa. In Europe, cities like Salzburg, literally meaning salt castle, in Austria built their wealth on salt mining and trading. The Via Salaria, an ancient Roman road, was constructed specifically for salt transportation from the Adriatic Sea to Rome. These routes weren't just paths for commerce, they became channels for cultural exchange, technological advancement, and political influence. Let's consider how these trade networks influenced resource management. Communities had to develop sophisticated systems to 1. Extract salt efficiently from mines or evaporation ponds. 2. Store and transport salt without loss or damage. 3. Establish fair trading practices and value systems. 4. Protect trade routes from bandits and competing interests. The management of salt resources led to some of the earliest examples of international trade agreements. Chinese emperors monopolized salt production, creating the Salt Gabelle, a tax system that continued until the 20th century. Venice's rise to power was partly due to its control of salt production in the Adriatic. Even the British East India Company used salt taxes as a tool of colonial control in India. Did you know that salt trade routes influenced the development of many modern cities? Liverpool, for instance, grew from a small fishing village to a major port partly due to its role in salt trading. The Erie Canal in New York was built partly to transport salt from Syracuse's salt springs to the rest of the country. The management of salt resources also led to significant technological innovations. The development of solar evaporation techniques, mining methods, and preservation processes all evolved alongside the salt trade. These innovations often transferred to other industries, contributing to broader technological advancement. Consider these fascinating examples of salt's influence on resource management. The development of standardized weights and measures to ensure fair trade. The creation of banking systems to handle large-scale salt transactions. The establishment of customs and tariff systems. the formation of trade guilds and merchant associations. The salt trade also taught valuable lessons about sustainable resource management. Communities learned to balance extraction rates with natural replenishment, maintain infrastructure for long-term production, develop alternative sources and routes to ensure supply stability, create storage systems to manage supply and demand fluctuations. Today's global trade networks owe much to these ancient salt routes. The principles of resource management developed during the height of the salt trade continue to influence modern business practices. For instance, the concept of strategic reserves, price stabilization, and international trade agreements all have roots in historical salt trade management. The story of the salt roads reminds us that effective resource management isn't just about controlling a commodity. It's about understanding its value to society, developing sustainable practices, and creating systems that benefit all parties involved. As we face modern challenges in resource management and international trade, the lessons from the salt roads remain remarkably relevant. What other ancient trade networks have shaped our modern world? How do the principles of resource management developed during the salt trade era apply to today's global challenges? These questions encourage us to look at current resource management issues through the lens of historical experience, helping us make better decisions for the future. The salt roads weren't just trade routes, they were the arteries of civilization, pumping life-giving commerce and culture across continents. They stand as a testament to human ingenuity in resource management and remind us that successful trade networks require more than just goods and services. They require cooperation, innovation, and sustainable practices that benefit all participants. Have you ever wondered how civilizations throughout history have managed to protect themselves from threats? Let's explore the fascinating world of military structures and protection systems that have shaped human defense strategies throughout the ages. At its core, defense is about creating layers of protection, much like an onion with its multiple layers. This concept, known as defense in depth, has been a fundamental military principle for thousands of years. But what exactly does it entail? Let's start with the most basic and visible form of military defense: walls. From the Great Wall of China to the medieval castles of Europe, walls have served as the first line of defense against invaders. These weren't just simple barriers, they were sophisticated systems incorporating multiple features. Take, for instance, a typical medieval castle wall. It would include battlements, the notched tops of walls, arrow slits, narrow openings for archers, and machicolations, openings through which defenders could drop objects on attackers. But what about the space before the walls? This is where the concept of defensive depth truly begins. Moats, both wet and dry, served as obstacles to keep enemies at bay. Some fortifications included multiple moats, creating successive barriers that attackers would need to cross. Beyond moats, there were often other obstacles like ditches, earthworks, and wooden stakes called palisades. Moving to more modern times, how did defensive structures evolve with the advent of gunpowder and artillery? The answer lies in the development of star forts, also known as tres Italiens. These structures, first appearing in the 15th century, were designed with angular bastions that eliminated blind spots and allowed defenders to fire along the walls, creating deadly crossfire zones. The walls were also made lower and thicker to better absorb cannon fire. But defense isn't just about physical barriers. Throughout history, military planners have utilized natural terrain as part of their defensive strategy. Mountains, rivers, forests, and deserts have all served as natural obstacles. Consider the Swiss Alps, which have helped Switzerland maintain its neutrality for centuries, or the English Channel, which has protected Britain from numerous potential invasions. In the modern era, how have defensive systems adapted to new threats? The advent of aerial warfare brought about new challenges, leading to the development of anti-aircraft systems, radar installations, and underground bunkers. The Cold War saw the creation of massive underground complexes, like Noradi's Cheyenne Mountain Complex, designed to withstand nuclear attacks. Today's military defensive structures incorporate advanced technology alongside traditional principles. Modern military bases often feature multiple security zones, each with increasing levels of security. These might include perimeter fencing with electronic surveillance, vehicle barriers and checkpoints, blast-resistant buildings, Hardened underground facilities. Electronic warfare countermeasures. Biological and chemical detection systems. But what about cyber defense? In our digital age, military protection extends beyond physical structures into the virtual realm. Modern military installations must defend against both physical and cyber attacks, creating multiple layers of security in both domains. Protection systems have also evolved to include active defense measures. These include early warning systems, anti-missile defense systems, electronic countermeasures, automated response systems, integrated air defense networks. The concept of defensive depth has expanded to include psychological and information warfare aspects. Military installations now include facilities for psychological operations, electronic warfare, and information warfare, recognizing that modern conflicts often take place in multiple domains simultaneously. Looking at civilian applications, how have military defensive principles influenced everyday security? Many modern security systems in civilian facilities, from airports to government buildings, incorporate military-inspired defensive concepts. These might include multiple security checkpoints, surveillance systems, and restricted access zones. What about the future of military defense? As technology continues to advance, new challenges and solutions emerge. Some areas of development include autonomous defense systems, artificial intelligence-powered security, quantum encryption for communications, advanced materials for protective structures, space-based defense systems. The principles of defense in depth remain constant even as the specific implementations evolve. Whether it's an ancient castle or a modern military base, the goal is to create multiple layers of protection that work together to deter, detect, and defend against threats. Understanding these defensive systems helps us appreciate the complexity of military protection and its evolution throughout history. From simple walls to sophisticated multi-domain defense networks, the fundamental principle remains the same: create multiple layers of protection that work together to ensure security. As we look to the future, how will defensive systems continue to evolve? What new challenges will emerge, and how will military planners adapt to meet them? These questions drive the ongoing development of military defensive structures and protection systems, ensuring they remain effective against ever-evolving threats. Let's dive deep into the fascinating world of underwater scientific achievements that have shaped our understanding of submerged civilizations. Have you ever wondered how ancient underwater societies managed to advance their scientific knowledge despite the challenging aquatic environment? The answer lies in their remarkable adaptability and innovative thinking. The underwater civilizations developed unique scientific methods and tools that were specifically designed to work in aquatic conditions. One of their most significant contributions was in the field of hydrodynamics. They discovered fundamental principles of fluid mechanics long before surface civilizations, as their daily lives depended on understanding water movement and pressure. Their studies led to the development of efficient underwater propulsion systems and the creation of structures that could withstand immense water pressure. In the realm of marine biology, these civilizations made groundbreaking discoveries. They were the first to document and classify thousands of marine species, creating detailed taxonomies that are still relevant today. Their intimate understanding of marine ecosystems led to sustainable farming practices underwater, including the cultivation of various species of algae and the domestication of certain fish species. But how did they manage to record their findings in an underwater environment? The answer lies in their development of waterproof writing materials. They created special tablets made from treated coral and mineral compounds that could withstand water exposure for extended periods. These tablets were used to document their scientific findings, mathematical calculations, and astronomical observations. Speaking of astronomy, you might wonder how they studied the stars from beneath the waves. They developed sophisticated instruments that could detect and measure celestial movements through water, using the refraction of light to their advantage. Mathematics and geometry flourished in these underwater societies. They developed complex mathematical systems based on base 8 rather than base 10, possibly influenced by the octagonal symmetry commonly found in marine life. Their understanding of geometry was particularly advanced, as they needed to calculate volumes and pressures accurately for their underwater construction projects. The field of chemistry saw remarkable progress under these civilizations. They discovered methods to extract minerals from seawater and developed techniques for preventing corrosion in their metal tools and structures. Their knowledge of marine chemistry led to the creation of waterproof adhesives and sealants, some of which were so effective that their compositions are still studied today. One of their most impressive achievements was in the field of acoustics. Living underwater, they developed a sophisticated understanding of sound waves and their behavior in water. This knowledge led to the creation of advanced communication systems using sound waves, similar to modern sonar technology. They could transmit messages over vast distances underwater, creating an efficient communication network that connected their cities. Medicine in these underwater civilizations took a unique direction. They discovered numerous marine compounds with medicinal properties and developed treatments for conditions specific to underwater living. Their understanding of pressure-related ailments and their treatments was particularly advanced. They also made significant progress in understanding human physiology under pressure, knowledge that proves valuable even in modern deep-sea exploration. In the field of environmental science, these civilizations were far ahead of their time. They developed methods to monitor water quality, temperature changes, and current patterns. Their understanding of marine weather patterns and their ability to predict underwater currents and temperature changes was remarkable. They created early warning systems for underwater volcanic activity and seismic disturbances, helping them protect their cities from natural disasters. The underwater civilizations also made significant contributions to materials science. They developed building materials that could withstand the corrosive effects of saltwater while maintaining structural integrity under high pressure. Their knowledge of natural polymers derived from marine organisms led to the creation of flexible yet durable materials used in construction and daily life. Energy generation was another area where these civilizations showed remarkable innovation. They harnessed the power of underwater currents, thermal vents, and pressure differentials to generate energy. Their understanding of underwater geothermal activity led to the development of sustainable energy systems that powered their cities. Perhaps one of their most enduring contributions was in the field of conservation science. They developed methods for sustainable resource management and understood the importance of maintaining ecological balance. Their practices of marine ecosystem preservation and species protection were far ahead of their time and offer valuable lessons for modern conservation efforts. The scientific achievements of underwater civilizations continue to amaze and inspire us today. Their unique perspective and innovative solutions to complex problems demonstrate the incredible adaptability of human intelligence. As we face modern challenges in marine science and underwater exploration, many of their discoveries and methods remain relevant and valuable. What other secrets might these advanced underwater societies have uncovered that we've yet to rediscover? Their legacy reminds us that scientific advancement can flourish in even the most challenging environments, and that necessity truly is the mother of invention. The underwater civilization's scientific achievements not only ensured their survival, but also contributed to the broader understanding of our marine world, leaving an indelible mark on the history of human scientific progress. Let's dive deep into the fascinating world of ocean floor mapping and navigation systems, exploring how we've evolved from basic depth measurements to sophisticated 3D underwater cartography. Have you ever wondered how we know what lies beneath the vast oceanic expanses? The journey of mapping the ocean floor began with simple lead line measurements, where sailors would drop weighted ropes to measure depth. This rudimentary technique, used for thousands of years, provided only isolated depth measurements. But how did we progress from these basic methods to today's detailed underwater maps? The real breakthrough in ocean floor mapping came with the invention of sonar, sound navigation and ranging, during World War I. Initially developed for detecting submarines, sonar technology revolutionized our understanding of seafloor topography. Sound waves are sent from ships, and by measuring the time they take to bounce back from the seafloor, we can calculate precise depths. This technique, known as echo sounding, revealed that the ocean floor isn't just a flat, featureless plane as once believed. Modern multi-beam sonar systems, introduced in the 1970s, marked another significant advancement. Unlike single-beam sonar, multi-beam systems emit multiple sound beams in a fan-shaped pattern, allowing ships to map wider areas of the seafloor in a single pass. This technology has revealed incredible underwater features such as seamounts, trenches, and submarine canyons with unprecedented detail. Satellite altimetry has also played a crucial role in ocean floor mapping. Satellites measure subtle variations in sea surface height, which reflect the gravitational effects of underwater topography. While not as detailed as ship-based sonar, satellite altimetry has helped create global maps of major seafloor features. Navigation systems for underwater exploration have evolved alongside mapping technologies. The Global Positioning System, GPS, doesn't work underwater, so how do submarines and underwater vehicles navigate? They use a combination of technologies. Inertial navigation systems, INS, use accelerometers and gyroscopes to track movement from a known starting position. Long baseline, LBL, acoustic positioning systems employ networks of seafloor beacons that emit sound signals, allowing vehicles to triangulate their position. Doppler velocity logs, DVL, measure speed relative to the seafloor using sound waves. The development of autonomous underwater vehicles, AUVs, has revolutionized ocean floor mapping. These robotic submarines can operate independently for extended periods, collecting high-resolution data in deep waters and under ice sheets where traditional survey ships cannot go. They've helped discover underwater volcanoes, hydrothermal vents, and ancient shipwrecks. Geographic Information Systems, GIS, have transformed how we process and visualize ocean floor data. These computer systems combine various data types, bathymetry, depth measurements, sediment samples, temperature readings, and more, to create comprehensive maps of the marine environment. Modern GIS tools allow scientists to analyze seafloor features in 3 dimensions and study changes over time. Despite these technological advances, it's surprising to learn that we've mapped less than 20% of the ocean floor in high resolution. Compare this to the complete mapping of Mars's surface. This gap in our knowledge has led to international efforts like the SEAB 2030 project, which aims to map the entire ocean floor by 2030. Accurate ocean floor maps are crucial for many applications. Cable and pipeline laying for telecommunications and energy infrastructure. Marine resource exploration and management. Marine protected area designation. Climate change research. Tsunami prediction. Navigation safety. Search and rescue operations. The importance of ocean floor mapping extends beyond scientific curiosity. These maps help us understand plate tectonics, ocean circulation patterns, and marine ecosystems. They're essential for predicting how changes in ocean currents might affect global climate patterns. Modern mapping efforts also reveal previously unknown features that challenge our understanding of marine geology. For instance, the discovery of underwater rivers and lakes, formed by dense salty water flowing along the seafloor, has expanded our knowledge of ocean chemistry and biology. The future of ocean floor mapping looks promising with emerging technologies. New developments in autonomous vehicles, artificial intelligence for data processing, and advanced sonar systems will help fill the gaps in our understanding of the seafloor. Crowdsourced bathymetry, where commercial ships contribute depth data during their regular voyages, is also becoming increasingly important. The field of ocean floor mapping demonstrates how technological innovation can unlock the secrets of our planet's least explored frontier. As we continue to map the remaining unknown areas, what other discoveries await in the depths? How will improved understanding of ocean topography help us address global challenges like climate change and resource management? Remember, every new map of the ocean floor is potentially a map of undiscovered resources, unknown ecosystems, and untold stories of Earth's geological history. The quest to map our ocean floors continues to be one of humanity's great exploratory endeavors, combining cutting-edge technology with the age-old human desire to understand what lies beneath the waves. In our journey through the mysteries of the deep ocean, we encounter one of the most fascinating aspects of underwater civilization: the preservation and advancement of knowledge through educational institutions. Have you ever wondered how an underwater society would maintain and pass on its collective wisdom? Let's explore the remarkable world of the sunken scholars. The foundation of underwater education. the establishment of educational institutions beneath the waves became a necessity as underwater communities grew and developed. These institutions, collectively known as the Sunken Scholars, emerged as centers of learning that adapted traditional educational methods to suit the unique challenges of underwater life. Primary education centers. At the foundation level, young members of underwater communities attend primary education centers, where they learn fundamental skills essential for life beneath the waves. These centers focus on basic pressure management and breathing techniques, understanding underwater communication systems, marine biology and ecosystem awareness, fundamental mathematics and sciences, historical studies of both surface and underwater civilizations. The architecture of learning. Unlike surface institutions, underwater educational facilities are designed with specific considerations in mind. Pressure-resistant dome structures, multiple emergency exits and safety chambers, specialized learning pods for practical training, advanced filtration and oxygen circulation systems, integration with natural marine formations, advanced research institutes. Beyond basic education, the Sunken Scholars maintain several specialized research institutes focusing on 1. Marine technology development. 2. Deep sea exploration. 3. Underwater agriculture. 4. Pressure physics. 5. Marine biology and conservation. Knowledge preservation methods. One of the most crucial aspects of underwater education is the preservation of knowledge. How do you maintain books and documents in an environment where water damage is a constant threat? The Sunken Scholars developed several innovative solutions. Digital archives, waterproof data storage systems, holographic libraries, pressure-resistant computer networks, backup systems in multiple locations, cloud storage synchronized with surface facilities, physical archives, specially treated water-resistant materials, pressurized document chambers, chemical preservation techniques, redundant copying systems, emergency evacuation protocols for valuable documents. The role of educators. Underwater educators, or Sunken Scholars, undergo extensive training beyond traditional teaching qualifications. Advanced diving certification, emergency response training, underwater communication expertise, specialized subject knowledge, environmental awareness training, research and development. The educational institutions serve as centers for ongoing research and development, new underwater technology testing, marine life studies, environmental impact assessment, pressure resistance improvements, communication system advances, international collaboration. The Sunken Scholars maintain strong connections with surface educational institutions through exchange programs, joint research projects, shared resources and knowledge, regular conferences and symposiums, cross-cultural educational initiatives, curriculum development. The underwater educational system follows a carefully structured curriculum that balances theoretical knowledge with practical skills. Core subjects: marine sciences, underwater engineering, environmental studies, mathematics and physics, history and social studies, communication technologies, practical training, survival skills, equipment maintenance, emergency procedures, navigation techniques, marine life interaction, continuing education. The Sunken Scholars recognize the importance of lifelong learning and offer adult education programs, professional development courses, skill upgrade workshops, specialization opportunities, research fellowships, technology integration. Educational technology plays a crucial role in underwater learning. Virtual reality training simulations, underwater communication devices, digital learning platforms, interactive holographic displays, remote learning capabilities, challenges and solutions. The underwater educational system faces unique challenges. 1. Pressure management, regular maintenance of facilities, structural integrity monitoring, emergency protocols, safety training. 2. Resource management, efficient use of materials, sustainable practices, waste reduction, energy conservation. 3. Communication, clear underwater communication systems, signal boosting technology, emergency backup systems, multiple communication channels, impact on society. The sunken scholars have significantly influenced underwater civilization through advanced research contributions, technological innovations, cultural preservation, knowledge dissemination, community development, future developments. The educational system continues to evolve with new teaching methodologies, advanced technology integration, expanded research capabilities, international partnerships, environmental adaptation strategies. The legacy of learning. The sunken scholars represent more than just educational institutions. They are the guardians of underwater civilization's knowledge and culture. Their role in preserving and advancing understanding while adapting to the unique challenges of underwater life demonstrates the remarkable capacity for human adaptation and innovation. As we conclude our exploration of the sunken scholars, we can appreciate the complexity and importance of maintaining educational systems in challenging environments. How will these institutions continue to evolve as underwater civilization advances? What new discoveries and innovations will emerge from these centers of learning? The answers to these questions will shape the future of underwater education and society as a whole. As we explore the fascinating realm of underwater urbanization, we must first understand what drives humanity to consider such an ambitious endeavor. Have you ever wondered how cities beneath the waves could become a reality? Let's dive deep into this compelling subject that's increasingly relevant in our modern world. Underwater urbanization represents the development and establishment of human habitats beneath the ocean's surface. This concept isn't merely science fiction anymore. It's becoming a serious consideration as our planet faces growing challenges with population density, climate change, and limited land resources. The fundamental principles of underwater urbanization begin with understanding the immense pressure that exists beneath the surface. At just 10 meters deep, the pressure is twice that at sea level, and this presents unique engineering challenges. Engineers and architects must design structures that can withstand these intense external forces while maintaining safe internal environments for human habitation. One of the primary considerations in underwater urban development is the creation of sustainable life support systems. Unlike traditional cities, underwater habitats must be entirely self-contained environments that provide clean air, fresh water, and waste management systems. These systems typically employ advanced filtration technologies and often integrate with marine ecosystems in ways that traditional cities never had to consider. The architecture of underwater cities follows specific patterns dictated by physics and engineering requirements. Most designs incorporate dome-shaped structures, as this form naturally distributes pressure evenly and provides the greatest structural integrity. These structures are typically constructed using reinforced materials, such as acrylic and steel composites, which offer both strength and transparency, allowing natural light to penetrate and providing views of the surrounding marine environment. Transportation in underwater cities presents unique challenges and opportunities. Traditional road systems are replaced by networks of pressurized tunnels connecting different sections of the city. Submarine vehicles and specialized transport pods become the primary means of moving between locations. These systems must be designed with multiple redundancies and safety features to prevent catastrophic failures. Energy generation in underwater cities takes advantage of their unique position. Tidal power, wave energy, and ocean thermal energy conversion (OTEC) become primary power sources. These renewable energy systems are often supplemented with hydrogen fuel cells and other sustainable technologies that can operate efficiently in marine environments. Population management in underwater cities requires careful planning and consideration. Space is at a premium, and every square meter must be utilized efficiently. This leads to the development of compact living spaces and multifunctional areas that can serve various purposes throughout the day. The psychological impact of living underwater must also be considered, with designs incorporating elements that help prevent claustrophobia and maintain mental well-being. Food production in underwater cities often relies on advanced aquaculture and hydroponic systems. These facilities are integrated into the city's structure, providing fresh produce and protein sources while minimizing the need for external supply chains. The proximity to marine resources also allows for sustainable harvesting of seafood, though this must be carefully managed to prevent ecosystem damage. Water management takes on new significance in underwater habitats. While surrounded by water, these cities must maintain sophisticated systems for purifying seawater into freshwater, managing wastewater, and preventing contamination of both the internal environment and the surrounding ocean ecosystem. These systems often employ multiple stages of filtration and treatment to ensure safety and sustainability. The environmental impact of underwater cities must be carefully monitored and managed. These developments can either harm or help marine ecosystems, depending on their design and implementation. Many underwater city proposals include artificial reefs and marine sanctuaries as integral components, promoting biodiversity while providing natural barriers against storms and currents. Emergency protocols in underwater cities are particularly crucial. Multiple escape routes, pressure-sealed compartments, and emergency life support systems must be incorporated into every section of the city. Regular drills and maintenance checks become part of daily life to ensure safety systems remain functional and residents know how to respond in crisis situations. The economic aspects of underwater urbanization are complex and multifaceted. The initial construction costs are significantly higher than traditional surface cities, but the potential benefits, including access to marine resources, energy generation, and new forms of tourism, can offset these expenses over time. The development of underwater cities also creates new job markets and industries, from submarine maintenance to marine agriculture. Legal frameworks for underwater cities present unique challenges as traditional property rights and governance systems must be adapted for these new environments. International maritime law, environmental regulations, and sovereignty issues all come into play when establishing underwater settlements. As we look to the future, underwater urbanization represents both a challenge and an opportunity. While the technical hurdles are significant, the potential benefits, including reduced land use pressure, access to new resources, and innovative solutions to climate change, make it an increasingly attractive option for future development. The success of underwater cities will depend on our ability to balance technological innovation with environmental stewardship, ensuring these new urban frontiers enhance rather than harm our planet's marine ecosystems. Have you considered how underwater cities might change our relationship with the ocean? As we continue to develop these ambitious projects, we must remember that we're not just building cities, we're creating new ways of living that could reshape humanity's future on our blue planet. The vast oceans, covering more than 70% of our planet, have become an extraordinary source of medical breakthroughs and healthcare innovations. Have you ever wondered how creatures living in the deepest parts of the ocean might hold the key to treating human diseases? Let's dive into the fascinating world of marine medicine and discover how the ocean's biodiversity contributes to modern healthcare. Marine organisms have evolved over millions of years to produce unique compounds that help them survive in extreme conditions. These compounds, known as marine natural products, MNPs, have become invaluable resources in medical research and drug development. Did you know that there are currently over 15 FDA-approved drugs derived from marine sources? One of the most significant breakthroughs in marine medicine came from the Caribbean sea squirt, Ectaenicidia turbinata. This small marine organism led to the development of Yondelis trabectedin, a powerful anti-cancer drug now used to treat soft tissue sarcomas and ovarian cancer. The discovery of this compound revolutionized our understanding of how marine organisms can contribute to fighting devastating diseases. Cone snails, despite their small size, have provided researchers with powerful pain medications. These mollusks produce conotoxins, which have led to the development of Praelt, ziconotide, a non-addictive pain medication that's 1,000 times more potent than morphine. This discovery has opened new possibilities for treating chronic pain without the risks associated with opioid medications. The ocean's contribution to medical science extends beyond drug development. Marine algae, particularly seaweed species, have become essential in medical research and applications. Carrageenan, derived from red algae, is widely used in pharmaceutical formulations as a stabilizing agent. Additionally, alginate from brown algae serves as a crucial component in wound dressings and dental impressions. Coral reefs, often called the rainforests of the sea, have provided groundbreaking solutions in bone grafting procedures. The structural similarity between coral calcium carbonate and human bone has led to the development of natural bone substitutes. These marine-derived materials promote bone growth and healing, revolutionizing orthopedic and dental surgeries. Marine sponges have emerged as one of the richest sources of bioactive compounds. These simple organisms have yielded substances with anti-inflammatory, antiviral, and anti-cancer properties. The discovery of Araceae citarabine from the Caribbean sponge Cryptotethia crypta has saved countless lives as a treatment for leukemia and lymphoma. Horseshoe crabs, living fossils that have existed for over 450 million years, contribute significantly to medical testing. Their blue blood contains a substance called Limulus amoebocyte lizette, LAL, which is essential for testing the sterility of medical equipment and injectable drugs. Every FDA-approved vaccine must be tested using LAL to ensure it's free from bacterial contamination. The development of marine medicine has also led to advances in biotechnology. Researchers have identified extremophiles, organisms that thrive in extreme conditions, in deep-sea hydrothermal vents. These organisms produce heat-stable enzymes that have applications in molecular biology and diagnostic testing. Marine toxins have paradoxically become valuable tools in medical research and treatment. Tetrodotoxin, found in pufferfish, is being studied as a potential local anesthetic and pain medication. Similarly, green fluorescent protein, GFP, from jellyfish has revolutionized our ability to study gene expression and cellular processes. The field of marine medicine has also expanded into the development of marine-derived biomaterials. Chitosan, obtained from crustacean shells, is used in wound healing, drug delivery systems, and tissue engineering. Its natural antibacterial properties and biocompatibility make it an ideal material for medical applications. Recent research has focused on marine microorganisms, which represent an untapped reservoir of potential medicines. These microscopic organisms produce unique metabolites that could lead to new antibiotics, a crucial development in the fight against antibiotic-resistant bacteria. The sustainable harvesting of marine organisms for medical purposes has become a critical consideration. Scientists are developing methods to synthesize these compounds in laboratories or cultivate the source organisms through aquaculture, ensuring the preservation of marine ecosystems while maintaining access to these valuable medical resources. Marine medicine has also contributed to the development of diagnostic tools. Compounds from marine organisms are used in medical imaging, and marine toxins serve as molecular probes for studying cellular processes and disease mechanisms. Looking ahead, the potential of marine medicine seems limitless. Researchers continue to discover new compounds with promising medical applications. The development of advanced technologies for deep-sea exploration and improved methods for studying marine organisms suggests that we have only scratched the surface of what the oceans can offer to medical science. As we face growing challenges in healthcare, from antibiotic resistance to the need for more effective cancer treatments, marine medicine remains a beacon of hope. The oceans continue to surprise us with their potential to provide solutions to human health problems, reminding us of the crucial importance of preserving these aquatic ecosystems for future medical discoveries. The integration of marine medicine into modern healthcare practices represents a perfect example of how nature's solutions can address human health challenges. As research continues and technology advances, we can expect even more breakthrough discoveries from our ocean's vast pharmaceutical treasure trove. As we dive into the fascinating world of deep-sea governance and social organization, let's explore how marine communities have developed sophisticated systems to maintain order and harmony in the depths. Have you ever wondered how marine ecosystems maintain their delicate balance? The answer lies in what scientists call the deep democracy. The concept of deep democracy in marine environments refers to the complex interconnected systems that regulate life in the oceans. Unlike terrestrial governance systems, marine governance operates on multiple levels, from microscopic organisms to large marine mammals, each playing a crucial role in maintaining ecological balance. One of the most fundamental aspects of deep democracy is the trophic cascade system. This hierarchical structure ensures resource distribution and population control throughout the marine ecosystem. At the top of this system are apex predators, such as sharks and killer whales, which regulate the populations of smaller predatory fish. These smaller predators, in turn, control the numbers of herbivorous fish, which affect algae and plant growth. This natural checks and balances system has evolved over millions of years. But how does this relate to governance? Marine ecosystems demonstrate a form of distributed leadership where no single species holds absolute control. Instead, each species contributes to the overall stability of the system. This natural democracy extends beyond predator-prey relationships to include complex symbiotic partnerships and cooperative behaviors. Consider the cleaning stations found on coral reefs. These are perfect examples of marine social organization where different species come together in mutual benefit. Smaller fish and shrimp set up cleaning stations where larger fish come to have parasites removed. This interaction demonstrates a sophisticated social contract. The larger fish refrain from eating the cleaners, while the cleaners provide a valuable service. Marine mammals, particularly dolphins and whales, exhibit some of the most advanced forms of social organization in the oceans. They form complex societies with distinct cultural traditions, dialects, and social hierarchies. Pods of killer whales, for instance, maintain stable family groups led by matriarchs who pass down knowledge through generations. This knowledge includes hunting techniques, migration routes, and social protocols. The deep democracy also manifests in the way marine organisms share resources. Coral reefs, often called the cities of the sea, demonstrate sophisticated resource allocation systems. Different species occupy various niches, from the reef surface to hidden crevices, each fulfilling specific roles in the community. This spatial organization helps prevent competition and promotes cooperation. Communication plays a vital role in marine governance systems. From the chemical signals released by coral during spawning events to the complex vocalizations of whales, marine organisms have developed various methods to coordinate group activities and maintain social order. These communication networks ensure the smooth functioning of marine communities and help them respond to environmental changes collectively. One of the most remarkable aspects of deep democracy is the way marine organisms make collective decisions. Schools of fish, for example, can make rapid directional changes as a unified group without any central leadership. This decentralized decision-making process, known as swarm intelligence, allows for quick responses to predators or environmental changes while maintaining group cohesion. The deep democracy also includes mechanisms for conflict resolution. Many marine species have developed ritualized behaviors to settle disputes without causing serious harm. Male seals, for instance, engage in displays of strength and posturing rather than deadly combat when competing for mates. This helps maintain social stability while ensuring the strongest individuals pass on their genes. Seasonal migrations demonstrate another aspect of marine governance. Many species undertake long-distance journeys following established routes passed down through generations. These migrations require complex coordination and timing, often synchronized with environmental cues and the movements of other species. The deep democracy extends to the smallest scales of marine life. Microscopic phytoplankton, responsible for producing much of Earth's oxygen, form vast communities that respond collectively to environmental conditions. Their population dynamics and distribution patterns affect entire ocean ecosystems, demonstrating how even the smallest organisms participate in marine governance. Understanding these natural governance systems has important implications for human management of marine resources. What lessons can we learn from these ancient and effective organizational systems? How can we better align our marine protection efforts with these natural governance structures? The deep democracy of marine ecosystems shows us that effective governance doesn't always require centralized control. Instead, it can emerge from the complex interactions between different components of a system, each playing its part in maintaining the whole. This understanding is crucial as we face increasing challenges in marine conservation and resource management. As we conclude our exploration of deep democracy in marine environments, we see that these governance systems represent millions of years of evolutionary refinement. They demonstrate principles of cooperation, resource sharing, and collective decision-making that continue to fascinate scientists and offer valuable insights for human society. What other secrets might these underwater democracies hold, and how can they inform our approach to environmental stewardship? Water has always been a fundamental element in human recreation and athletic pursuits. Throughout history, our relationship with aquatic environments has evolved from basic survival skills to sophisticated sporting activities that challenge our physical abilities and push the boundaries of human performance. Let's begin by understanding what makes aquatic athletics unique. Have you ever wondered why swimming feels so different from running or walking? The answer lies in water's physical properties. Water is approximately 800 times denser than air, which means every movement in water requires more effort and engages different muscle groups than land-based activities. This resistance creates a full-body workout that has made aquatic athletics increasingly popular for both competition and fitness. Swimming, the cornerstone of aquatic athletics, has been part of the Olympic Games since 1896. The sport has evolved to include 4 main competitive strokes: freestyle, breaststroke, backstroke, and butterfly. Each stroke has its own fascinating history and development. For instance, did you know that the butterfly stroke was originally a variation of the breaststroke? It wasn't until 1952 that it was recognized as a separate competitive stroke. Water polo, another prominent aquatic sport, combines swimming endurance with ball handling skills. This demanding sport originated in Great Britain in the late 19th century as a form of rugby played in rivers and lakes. Today, it's played in a pool where athletes must tread water continuously while passing, catching, and shooting a ball into the opponent's goal. The sport requires exceptional stamina, as players cannot touch the bottom or sides of the pool during play. Diving represents the artistic side of aquatic athletics. Competitive diving is judged on 3 main aspects: the approach and takeoff, the flight through the air, and the entry into the water. Modern diving competitions include events from both springboard and platform heights, with divers performing increasingly complex combinations of twists, somersaults, and rotations. Synchronized swimming, now known as artistic swimming, showcases the perfect blend of athletic ability and artistic expression. This sport demands incredible strength, flexibility, and lung capacity as athletes perform choreographed routines while upside down for significant portions of their performances. Athletes must maintain precise timing with their teammates while executing complex movements, often while holding their breath for extended periods. Open water swimming has gained significant popularity in recent years. This discipline takes place in natural bodies of water and tests athletes' endurance, navigation skills, and ability to adapt to changing conditions. The sport became an Olympic event in 2008, featuring a 10-kilometer marathon swim. Open water swimming challenges athletes to cope with variables like water temperature, currents, and weather conditions that aren't present in pool-based events. Surfing, while not traditionally categorized with competitive swimming sports, is another significant aquatic athletic pursuit. The sport made its Olympic debut in Tokyo 2020, recognizing the skill, athleticism, and dedication required to master wave riding. Surfing combines balance, strength, and an intimate understanding of ocean dynamics. The development of aquatic athletics has also led to innovative training methods and technologies. Underwater cameras help coaches analyze technique, while advanced swimwear materials have revolutionized competitive swimming. Remember the controversy over full-body swimsuits in 2008 to 2009. These suits led to numerous world records before being banned for providing unfair advantages. Aquatic athletics have also proven valuable in rehabilitation and therapy. The buoyancy of water reduces impact on joints while providing resistance for strength training. This has made aquatic exercise particularly beneficial for individuals recovering from injuries or managing chronic conditions. Safety remains a paramount concern in all aquatic activities. The development of lifeguarding as a profession has paralleled the growth of aquatic athletics. Modern lifeguards undergo rigorous training in rescue techniques, first aid, and emergency response procedures to ensure the safety of both recreational and competitive athletes. The future of aquatic athletics continues to evolve with new disciplines emerging. Stand-up paddleboarding, underwater hockey, and aquajogging are gaining popularity, expanding the definition of what constitutes aquatic sports. These activities offer new challenges and opportunities for athletes of all abilities to engage with water-based exercise. The accessibility of aquatic athletics varies globally, influenced by factors such as climate, infrastructure, and cultural attitudes towards swimming. Many organizations work to promote water safety and swimming education, recognizing these as essential life skills as well as gateways to athletic participation. Looking ahead, aquatic athletics face both opportunities and challenges. Climate change affects natural swimming environments, while pool maintenance costs and access to facilities remain ongoing concerns. However, technological advances and growing recognition of the health benefits of water-based exercise continue to drive innovation and participation in aquatic sports. Understanding aquatic athletics helps us appreciate the unique challenges and rewards of water-based sports. Whether competing at an elite level or enjoying recreational swimming, participants in aquatic athletics develop physical fitness, mental discipline, and a special relationship with the aquatic environment. What aquatic activity might you try next? Have you ever wondered what lies beneath the ocean's surface, not just in terms of marine life, but in terms of sound? The underwater world is filled with fascinating acoustic phenomena that have captivated scientists, musicians, and engineers for generations. Let's dive deep into the realm of submarine sound and discover how sound behaves differently underwater compared to air. First, let's understand why sound travels differently underwater. In water, sound waves move about 4 times faster than they do in air, approximately 1,500 meters per second compared to 343 meters per second in air. This difference creates unique challenges and opportunities for both marine life and human technology. But why does this happen? The answer lies in the density and molecular structure of water. Water molecules are packed much closer together than air molecules, allowing sound waves to transfer energy more efficiently. The history of submarine sound research begins with early naval operations. During World War I, submarines became a significant military threat, leading to the development of sonar, sound navigation and ranging. This technology revolutionized our understanding of underwater acoustics and opened new possibilities for marine exploration. Sonar works by sending sound waves into the water and measuring the time it takes for the echo to return, allowing us to detect objects and measure distances underwater. Marine mammals have been using their own version of sonar long before humans invented it. Whales and dolphins use echolocation to navigate, communicate, and hunt. They produce various clicks, whistles, and songs that can travel for miles underwater. The blue whale, for instance, can produce sounds that reach up to 188 decibels, louder than a jet engine, and these sounds can travel for hundreds of miles through the ocean. The development of underwater acoustic technology has led to numerous applications beyond military use. Scientists use hydrophones, underwater microphones, to study marine life, monitor ocean health, and track underwater geological activities. These devices have revealed an incredibly rich acoustic environment beneath the waves, from the crackling of snapping shrimp to the haunting songs of humpback whales. But how does submarine sound affect marine life? The increase in human-generated ocean noise, including shipping traffic, offshore construction, and seismic surveys, has raised concerns about its impact on marine ecosystems. Many marine animals rely on sound for survival, and excessive noise pollution can interfere with their ability to communicate, navigate, and find food. The field of underwater acoustics has also influenced music and art. Composers and sound artists have created works specifically designed to be performed or experienced underwater. Special underwater speakers and listening equipment have been developed to accommodate these unique performances. Have you ever wondered what your favorite song would sound like if you listened to it underwater? The science of submarine sound has practical applications in various industries. Oil and gas companies use acoustic surveys to locate underwater resources. Marine biologists use passive acoustic monitoring to track whale migrations and study their behavior. Underwater construction projects rely on sound measurement to ensure structural integrity and worker safety. One fascinating aspect of submarine sound is the existence of the SOFAR channel, sound fixing and ranging. This is a natural underwater sound channel where acoustic waves can travel thousands of miles with minimal loss of energy. This phenomenon occurs due to variations in water temperature and pressure at different depths, creating a kind of underwater sound highway. The future of submarine sound technology continues to evolve. Scientists are developing more sophisticated acoustic systems for ocean mapping, climate monitoring, and underwater communication. New applications include underwater internet networks using sound waves to transmit data between submerged devices and surface vessels. Understanding submarine sound has also contributed to marine conservation efforts. By monitoring underwater soundscapes, scientists can assess ecosystem health and identify potential threats to marine life. This information helps in developing more effective conservation strategies and regulations to protect ocean environments. The relationship between submarine sound and weather patterns is another important area of study. Underwater acoustic measurements can help detect approaching storms, track ocean currents, and monitor climate change impacts on marine environments. The ocean's acoustic properties provide valuable data for weather forecasting and climate research. As we continue to explore and understand submarine sound, new questions and challenges emerge. How can we better balance human activities with the acoustic needs of marine life? What new technologies might emerge from our growing understanding of underwater acoustics? The field of submarine sound remains an active area of research, promising new discoveries and applications in the years to come. In conclusion, submarine sound represents a fascinating intersection of physics, biology, technology, and environmental science. From its crucial role in marine life communication to its applications in human technology, understanding underwater acoustics has enhanced our knowledge of the ocean and our ability to interact with the marine environment. As we face growing environmental challenges, this understanding becomes increasingly important for ocean conservation and sustainable marine resource management. Throughout human history, few items have captured both economic and aesthetic value quite like pearls. Let's dive into the fascinating world of the pearl economy, exploring how these lustrous gems have shaped trade, currency, and social systems across civilizations. Have you ever wondered why pearls became such valuable commodities? The answer lies in their unique combination of rarity, beauty, and the challenging process of their formation and collection. Natural pearls form when an irritant, such as a grain of sand, enters an oyster or mussel. The mollusk then secretes layers of nacre, mother of pearl, around the irritant as a defense mechanism, creating what we know as a pearl. This process, occurring entirely by chance in nature, made natural pearls extremely rare and valuable. The pearl economy has ancient roots, dating back thousands of years. In ancient China, pearls were so highly valued that they were reserved exclusively for royalty. The Chinese even developed one of the earliest known pearl cultivation techniques during the 13th century, though these methods were quite different from modern practices. Similarly, in ancient Rome, pearls became a symbol of status and wealth, with Julius Caesar passing a law limiting pearl ownership to specific social classes. The Arabian Gulf region presents one of the most compelling examples of a pearl-based economy. Before the discovery of oil, pearl diving was the primary economic activity in many Gulf states, particularly Bahrain, Kuwait, and what is now the United Arab Emirates. From the 18th to the early 20th century, these regions operated almost entirely on a pearl-based economy. The annual pearl diving season would see thousands of boats and tens of thousands of divers searching for these precious gems. But how did pearls function as currency? Unlike modern currency systems, pearls had intrinsic value based on their size, shape, luster, and color. They were easily transportable, relatively durable, and universally recognized as valuable, making them an ideal medium of exchange in many societies. Traders could carry substantial wealth in a small pouch, facilitating international commerce across the ancient world's trade routes. The pearl economy created complex social and economic structures. In the Arabian Gulf, for instance, a sophisticated financial system developed around pearl diving. Boat captains would receive financing from pearl merchants, who would then advance money to the crew's families during the diving season. The profits would be shared according to established traditions, creating a complete economic ecosystem. However, the traditional pearl economy faced a dramatic transformation in the early 20th century. What caused this significant change? Two major factors: the development of cultured pearls and the Great Depression. Kokishi Mikimoto's successful development of cultured pearl techniques in Japan revolutionized the pearl industry. By 1935, Japanese cultured pearls had flooded the market, causing natural pearl prices to plummet. This technological advancement democratized pearl ownership but devastated traditional pearl diving economies. The economic impact was profound. Traditional pearl diving communities had to adapt or face economic collapse. Many Gulf states were fortunate to discover oil around this time, which became their new economic foundation. However, the transition wasn't smooth for all communities, and some traditional pearl diving regions faced significant hardship. Today's pearl economy looks vastly different from its historical counterpart. The global pearl market is now dominated by cultured pearls, with natural pearls becoming increasingly rare and valuable. The industry has evolved into a sophisticated market with different grades, types, and price points. China has emerged as the world's largest pearl producer, primarily farming freshwater pearls, while Japanese and Australian operations focus on high-end saltwater cultured pearls. The pearl economy also teaches us valuable lessons about economic adaptation and sustainability. The collapse of traditional pearl diving economies demonstrates how technological innovations can disrupt established economic systems. It shows how communities must adapt to changing economic conditions and diversify their economic bases to survive. The environmental aspect of the pearl economy is equally significant. Pearl farming requires clean, unpolluted waters to produce high-quality pearls. This has led to increased environmental awareness and conservation efforts in pearl-producing regions, as the industry's success depends directly on maintaining healthy marine ecosystems. Looking at modern luxury markets, pearls continue to hold significant economic value, though their role has shifted from currency to luxury commodity. The global pearl market is estimated to be worth billions of dollars annually, with demand driven by jewelry and luxury goods markets. The pearl economy serves as a fascinating example of how a single commodity can shape societies, drive technological innovation, and influence environmental conservation. It demonstrates the complex interplay between natural resources, human ingenuity, and economic systems, while also highlighting the importance of adaptability in the face of technological and economic change. As we reflect on the pearl economy's evolution, what lessons can we apply to modern economic challenges? How might current luxury commodities face similar disruptions from technological innovations? The story of the pearl economy continues to offer valuable insights into economic transformation, adaptation, and the delicate balance between tradition and innovation in global markets. Let's embark on a fascinating journey through the development of mathematics and astronomy in maritime history. Have you ever wondered how ancient sailors managed to navigate vast oceans without GPS or modern technology? The answer lies in the remarkable intersection of mathematics and maritime exploration. In the early days of seafaring, mathematics played a crucial role in solving practical navigation problems. One of the most fundamental challenges was determining a ship's position at sea. This led to the development of various mathematical techniques and tools that we still use today, albeit in more advanced forms. The concept of latitude was one of the first mathematical principles mastered by ancient mariners. By measuring the angle between the horizon and celestial bodies, like the North Star or the Sun, sailors could calculate their distance from the equator. This process required understanding basic trigonometry and angular measurements. The development of tools like the astrolabe and quadrant made these calculations possible, marking a significant advancement in marine mathematics. But what about longitude? This presented a much more complex mathematical challenge that wouldn't be fully solved until the 18th century. The problem was so significant that in 1714, the British government offered a substantial reward, £20,000, for anyone who could solve it. This became known as the Longitude Prize, highlighting the crucial importance of mathematical solutions in maritime navigation. The mathematical principles of dead reckoning emerged as another vital component of marine navigation. This involved calculating a ship's position based on its last known location, speed, and direction of travel. Sailors had to master basic arithmetic, geometry, and time calculations to perform these essential computations. They needed to understand concepts like distance, speed, and time relationships, which we now express through the formula: distance equals speed x time. Marine mathematics also encompassed the development of nautical charts and maps. The challenge of representing the Earth's spherical surface on a flat surface led to various mathematical projections. Mercator's projection, developed in 1569, became particularly important for navigation. This mathematical technique preserved angles and shapes, making it easier for sailors to plot straight-line courses. The study of tides required another layer of mathematical understanding. Sailors needed to predict tidal patterns, which involved complex calculations based on the Moon's gravitational pull and its position relative to Earth. This led to the development of tide tables, which required understanding periodic functions and basic astronomy. Speaking of astronomy, its relationship with marine mathematics cannot be overstated. The development of almanacs containing precise astronomical calculations became essential for navigation. These included detailed mathematical tables showing the positions of the sun, moon, and various stars throughout the year. Sailors had to learn how to use these tables and perform the necessary calculations to determine their position. The mathematical principle of triangulation became fundamental in marine navigation. By taking bearings on 3 known points, sailors could calculate their position through simple geometry. This technique required understanding basic trigonometry and the properties of triangles. As maritime trade expanded, so did the need for accurate calculations of cargo capacity and weight distribution. This led to the development of mathematical formulas for calculating ship displacement, stability, and cargo loading. These calculations were crucial for ensuring safe voyages and efficient trade operations. The development of marine insurance also required mathematical expertise. Underwriters needed to calculate risks and premiums based on various factors, leading to the early development of probability theory and statistics in a maritime context. The mathematical challenges of maritime navigation also spurred technological innovation. The invention of the chronometer by John Harrison, which finally solved the longitude problem, required precise mathematical calculations and engineering. This breakthrough demonstrated how mathematical principles could be applied to create practical solutions for maritime challenges. Marine mathematics continues to evolve today, though in different forms. Modern navigation systems still rely on the same basic mathematical principles, but computers now perform most calculations. However, understanding these fundamental concepts remains important for maritime professionals. The legacy of marine mathematics extends beyond navigation. Many mathematical principles developed for maritime purposes have found applications in other fields. For instance, spherical trigonometry, initially developed for celestial navigation, is now used in various scientific disciplines. As we reflect on the history of marine mathematics, we can appreciate how the practical needs of seafaring drove mathematical innovation. From basic arithmetic to complex astronomical calculations, mathematics has been the backbone of maritime navigation and commerce. The next time you use GPS navigation or check a tide table, remember the centuries of mathematical development that made these tools possible. What other mathematical challenges do you think ancient sailors faced? How do you think modern technology has changed the way we apply mathematics in maritime settings? These questions remind us that the relationship between mathematics and maritime activities continues to evolve, shaping our understanding of both fields. Let's dive into one of the most fascinating aspects of ancient maritime civilizations, their literature and record-keeping methods. Have you ever wondered how ancient seafaring peoples kept track of their stories, trade records, and maritime knowledge? The answer lies in the remarkable development of writing systems specifically adapted to maritime life. The maritime communities of the ancient world faced unique challenges when it came to preserving their knowledge. Unlike land-based civilizations that could easily store clay tablets or papyrus scrolls in dry libraries, seafarers needed methods that could withstand the harsh marine environment. This necessity led to the development of specialized writing techniques and materials that could survive exposure to salt water and humid conditions. One of the most significant innovations came from the Phoenicians, who were renowned maritime traders. Their alphabetic writing system, developed around 1050 BCE, was specifically designed to be simple enough for merchants to learn and use in their trading activities. This system was revolutionary because it used just 22 characters, making it much easier to master than the complex hieroglyphic or cuneiform systems of the time. The Phoenician alphabet became so effective that it formed the basis for many modern writing systems, including Greek, Latin, and Arabic scripts. The Greeks, building upon the Phoenician system, made their own significant contributions to maritime literature. They developed detailed ship logs, known as periplus, which contained valuable information about sailing routes, harbor locations, and coastal landmarks. These documents were essential for navigation and trade, serving as the ancient equivalent of modern sailing manuals. The Greek historian Herodotus, for instance, compiled extensive accounts of maritime expeditions, providing us with valuable insights into ancient seafaring practices. In the realm of record-keeping, maritime communities developed sophisticated methods for tracking their commercial activities. The development of tally sticks, a form of record-keeping where notches were carved into wooden sticks, became particularly popular among seafaring traders. These sticks could be split lengthwise, with each party keeping one half as proof of transaction, an early form of accounting that was particularly well-suited to maritime trade. The Romans further advanced maritime record-keeping with their development of detailed shipping registers. These documents recorded information about vessel ownership, cargo manifests, and port duties. The Romans also established a complex system of maritime law known as lex rhodia, Rhodian law, which required careful documentation of shipping agreements and dispute resolutions. In the Far East, Chinese mariners developed their own unique systems for maritime documentation. During the Song Dynasty 960-1279 CE, they created detailed nautical charts called needle charts that combined written descriptions with magnetic compass directions. These charts were accompanied by extensive written guides describing ocean currents, astronomical navigation methods, and port information. The preservation of maritime knowledge also took the form of oral traditions, particularly in Polynesian cultures. These seafaring peoples developed complex systems of memorized navigation charts, which were passed down through generations in the form of chants and stories. While not written in the conventional sense, these oral traditions were highly sophisticated methods of recording and transmitting maritime knowledge. Islamic maritime cultures made significant contributions to nautical literature during the medieval period. Arab navigators produced detailed sailing directories called Romani, which contained comprehensive information about the Indian Ocean's winds, currents, and ports. These documents were essential for the thriving Indian Ocean trade networks and demonstrated remarkable accuracy in their descriptions of maritime conditions. The development of waterproof materials for writing was another crucial innovation. Maritime communities experimented with various substances to protect their written records from water damage. Some used wax tablets that could be reused and were relatively water-resistant, while others developed water-resistant inks and specialized papers treated with protective substances. The impact of these maritime writing and record-keeping systems extended far beyond their original purposes. They facilitated international trade, enabled the spread of knowledge across vast distances, and helped establish some of the first international standards for commercial transactions. Many of these ancient systems laid the groundwork for modern maritime documentation practices, including bills of lading, ship's logs, and international maritime law. The evolution of maritime literature and record-keeping methods demonstrates the incredible ingenuity of ancient seafaring peoples. They not only developed practical solutions for preserving knowledge in challenging conditions, but also created systems that would influence writing and documentation practices for millennia to come. Their contributions continue to resonate in our modern maritime practices, reminding us of the enduring importance of effective communication and record-keeping in maritime activities. This rich history of maritime literature and record-keeping methods shows us how necessity truly is the mother of invention. The challenges faced by ancient mariners in preserving their knowledge led to innovations that would shape the course of human communication and commerce. As we continue to develop new technologies for maritime documentation in the digital age, we build upon this remarkable legacy of the water riders who came before us. As we explore the fascinating world of underwater cities and their complex international relations, let's dive deep into how these subaqueous metropolises interact with each other. Have you ever wondered how communities living beneath the waves maintain diplomatic ties? How do they resolve conflicts, establish trade agreements, and work together for the common good of their underwater civilization? The foundation of deep-sea diplomacy emerged from the necessity to manage shared resources and address common challenges faced by underwater settlements. Unlike surface diplomacy, underwater diplomatic relations must consider unique factors such as ocean currents, marine territories, and the delicate balance of marine ecosystems. One of the primary aspects of deep-sea diplomacy is the establishment of underwater territories. These boundaries are not simply drawn on maps, but are carefully determined using natural features like trenches, ridges, and thermal vents. The International Seabed Authority, ISA, plays a crucial role in mediating territorial disputes and ensuring fair distribution of resources among underwater cities. Trade relations form another vital component of deep-sea diplomacy. Underwater cities have developed sophisticated systems for exchanging goods and services. What makes these trade networks unique is their heavy reliance on sustainable practices to protect marine environments. For instance, trade routes are carefully planned to avoid disrupting marine life migration patterns and coral reef systems. Resource management agreements are particularly critical in deep-sea diplomacy. Cities must coordinate their efforts in harvesting marine resources, from mineral extraction to aquaculture. These agreements often include strict quotas and environmental impact assessments to prevent overexploitation and maintain ecological balance. The concept of blue diplomacy has emerged as a specialized field focusing on marine conservation efforts between underwater cities. This includes joint initiatives to protect endangered marine species, maintain coral reef health, and combat ocean pollution. How do these cities balance their development needs with environmental preservation? Communication infrastructure plays a vital role in maintaining diplomatic relations. Underwater cities have developed advanced networks using sonic technology and fiber optic cables to enable real-time communication. These systems are crucial for everything from daily diplomatic exchanges to emergency response coordination. Crisis management is another essential aspect of deep-sea diplomacy. Underwater cities must be prepared to respond collectively to various challenges, such as seismic activity, marine storms, or technical failures in life support systems. International protocols have been established for mutual assistance during emergencies. Cultural exchange programs have become increasingly important in strengthening ties between underwater communities. These initiatives include educational partnerships, artistic collaborations, and scientific research projects. How do these cultural connections help build stronger diplomatic relationships? The establishment of underwater embassies represents a significant development in deep-sea diplomacy. These facilities serve as permanent diplomatic missions, staffed by trained aqua diplomats who specialize in subaqueous international relations. What unique challenges do these underwater diplomats face in their daily work? Joint security arrangements are crucial for protecting underwater cities from various threats. This includes coordinated efforts to monitor marine territory, prevent unauthorized access, and maintain safe navigation channels. How do underwater cities balance security needs with open diplomatic relations? Conflict resolution mechanisms have been developed specifically for underwater disputes. These include specialized arbitration panels and mediation processes that consider the unique aspects of submarine life and resource management. What role do neutral third parties play in resolving underwater conflicts? Economic cooperation forms a cornerstone of deep-sea diplomatic relations. Cities often collaborate on large-scale infrastructure projects, research initiatives, and technological development. These partnerships help distribute costs and risks while promoting innovation in underwater living solutions. The concept of submarine citizenship has emerged as underwater cities develop more integrated communities. This raises interesting questions about identity and belonging in the underwater world. How do diplomatic relations address the movement of people between underwater cities? International law has evolved to accommodate the unique needs of underwater communities. The United Nations Convention on the Law of the Sea has been supplemented with specific provisions for subaqueous settlements. These legal frameworks provide the foundation for formal diplomatic relations. Looking to the future, deep-sea diplomacy continues to evolve as underwater cities face new challenges and opportunities. Climate change, technological advancement, and growing populations all influence how these communities interact and cooperate. What new diplomatic approaches will emerge as underwater civilization continues to develop? The success of deep-sea diplomacy relies heavily on maintaining open channels of communication and fostering mutual understanding between underwater communities. As these cities continue to grow and develop, their diplomatic relationships will play an increasingly important role in shaping the future of human civilization beneath the waves. This complex network of international relations demonstrates how underwater cities have adapted traditional diplomatic practices to their unique environment while developing new approaches to address their specific needs and challenges. What lessons can surface diplomacy learn from these underwater diplomatic innovations? As we explore the theories surrounding the ultimate fate of underwater civilizations, we must first acknowledge the complex interplay of factors that could determine their destiny. What really awaits these remarkable underwater societies that humanity has established? Let's dive deep into the various scientific predictions and expert analyses that shed light on this crucial question. First and foremost, we need to understand that underwater civilizations face unique challenges that their surface counterparts don't encounter. The constant pressure of the ocean depths, the corrosive nature of saltwater, and the dependence on complex life support systems all play critical roles in determining their long-term viability. But what does this mean for their future? One predominant theory, supported by marine engineers and oceanographers, suggests that underwater civilizations might face what they call infrastructure fatigue. Over time, even the most advanced materials used in constructing underwater habitats will experience wear and tear from constant exposure to high pressure and corrosive elements. This isn't just about maintenance, it's about the fundamental limits of our current engineering capabilities. Studies from the Global Underwater Research Institute indicate that even with regular maintenance, most underwater structures have a theoretical maximum lifespan of 150 to 200 years before major rebuilding becomes necessary. But there's more to consider than just structural integrity. The energy requirements for maintaining underwater civilizations are astronomical. Current projections show that as these communities grow, their energy needs increase exponentially. Why? Because every aspect of life underwater requires power, from maintaining optimal pressure and temperature to producing food and recycling air. The International Submarine Energy Commission has calculated that a typical underwater city of 10,000 inhabitants consumes as much energy as a surface city of 100,000 people. Another critical factor is the psychological impact of long-term underwater living. Research from the Submarine Psychological Studies Center has documented what they term aquatic claustrophobia syndrome, a condition that affects approximately 15% of long-term underwater residents. This psychological aspect raises important questions about the multi-generational viability of underwater societies. But perhaps the most intriguing theory about the fate of underwater civilizations comes from environmental scientists. They propose what they call the adaptation hypothesis. This theory suggests that over several generations, underwater communities might develop unique physiological and technological adaptations that could fundamentally change what it means to be human. Some researchers even speculate about the possibility of genetic modifications that could enhance human ability to live underwater more naturally. The economic sustainability of underwater civilizations is another crucial factor in predicting their fate. The cost of maintaining these underwater habitats is astronomical. According to the World Submarine Economic Forum, the annual maintenance cost of a medium-sized underwater city is approximately triple that of a similarly sized surface city. This raises questions about long-term economic viability. Can these communities generate enough economic activity to sustain themselves indefinitely? Climate change also plays a significant role in these predictions. Rising sea levels and changing ocean chemistry could have both positive and negative impacts on underwater civilizations. While rising seas might make surface living more challenging in some regions, potentially driving more people underwater, changes in ocean acidity and temperature could create new challenges for submarine structures and systems. A particularly concerning theory is the cascade failure scenario proposed by the International Underwater Safety Coalition. This theory suggests that underwater civilizations are particularly vulnerable to chain reactions of system failures. Because all systems are interconnected and essential for survival, the failure of one critical system could potentially trigger a catastrophic sequence of events. However, it's not all doom and gloom. Technological advancements continue to provide new solutions to these challenges. The development of self-repairing materials, more efficient energy systems, and improved psychological support systems offers hope for the long-term sustainability of underwater living. The evolutionary city theory proposed by submarine urban planners suggests that underwater cities might eventually evolve into something entirely different from their initial design. They might become hybrid structures, partially submerged and partially floating, adapting to changing needs and technological capabilities. The role of artificial intelligence and automation is expected to be crucial in the future of underwater civilizations. AI systems could potentially manage complex life support systems more efficiently than human operators, reducing the risk of human error and improving overall safety. One of the most optimistic theories comes from the field of marine biotechnology. Researchers are exploring the possibility of developing biological solutions to technical problems, for example, engineered organisms that could help maintain structure integrity or assist in waste processing. As we consider these various theories about the ultimate fate of underwater civilizations, one thing becomes clear: their future will likely depend on our ability to innovate and adapt to challenges we haven't even encountered yet. The question isn't just whether these civilizations will survive, but how they will evolve and what form they will take in the centuries to come. What's certain is that the fate of underwater civilizations is inextricably linked to humanity's broader future. As we continue to face challenges on the surface, from climate change to population growth, these underwater communities might represent not just an alternative way of living, but potentially a crucial part of humanity's long-term survival strategy. The profound influence of ancient underwater civilizations on modern marine archaeology and our understanding of human history continues to shape scientific research and exploration. Let's dive into how these submerged secrets have transformed our approach to understanding our past and what it means for future discoveries. Have you ever wondered how marine archaeologists piece together the puzzle of underwater civilizations? The legacy of submerged settlements has revolutionized archaeological methods and technologies. Traditional archaeology had to adapt significantly to explore underwater sites, leading to remarkable innovations in underwater excavation techniques. These advancements weren't just about developing better diving equipment, they represented a complete shift in how we approach historical research. The impact on modern marine archaeology began with the development of specialized tools and techniques. Remote sensing technologies like side-scan sonar and multi-beam echo sounders now allow archaeologists to create detailed maps of underwater sites without even getting wet. But what makes these tools so revolutionary? They can detect subtle changes in the seafloor that might indicate human settlement, from ancient harbor structures to submerged building foundations. One of the most significant contributions to modern archaeology has been the refinement of underwater excavation methods. The challenges of working in aquatic environments forced archaeologists to develop new preservation techniques. When artifacts are recovered from underwater sites, they require specialized treatment to prevent deterioration after centuries of submersion. This knowledge has proven invaluable not just for marine archaeology, but for conservation science as a whole. The discovery of underwater civilizations has also transformed our understanding of ancient maritime trade and migration patterns. By studying submerged ports and harbors, archaeologists have reconstructed ancient trading routes with unprecedented accuracy. This information has challenged previous assumptions about the capabilities of ancient civilizations and their interconnectedness. But what about the future? The legacy of underwater discoveries continues to influence how we approach marine exploration. Modern research vessels now employ autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, equipped with high-resolution cameras and sampling tools. These technologies allow us to explore deeper waters and more challenging environments than ever before. The impact extends beyond technology to affect our theoretical understanding of human adaptation to environmental change. Studying how ancient societies responded to rising sea levels provides valuable insights for modern coastal communities facing similar challenges. What can we learn from these submerged settlements about resilience and adaptation? The legacy of underwater civilizations has also influenced international law and heritage preservation. The UNESCO Convention on the Protection of Underwater Cultural Heritage, established in 2001, represents a global commitment to preserving submerged historical sites. This framework ensures that underwater cultural heritage is protected for future generations and that archaeological research follows established scientific standards. Marine archaeology has become increasingly interdisciplinary, combining elements of geology, climatology, biology, and anthropology. This holistic approach has enhanced our understanding of how ancient societies interacted with their environment and how environmental changes influenced human development. The study of underwater sites has revealed complex relationships between human settlements and coastal ecosystems that continue to inform modern coastal management practices. The future of marine archaeology looks promising, with new technologies emerging regularly. Photogrammetry and 3D modeling allow archaeologists to create detailed digital reconstructions of underwater sites, making them accessible to researchers and the public alike. These virtual models preserve information about sites that might deteriorate over time and enable collaborative research across international boundaries. Looking ahead, what discoveries might still await us in the depths? Current estimates suggest that we've explored less than 20% of the world's oceans, leaving vast areas potentially containing undiscovered archaeological sites. Rising sea levels throughout human history mean that countless coastal settlements likely remain hidden beneath the waves. The legacy of underwater civilizations continues to challenge our assumptions about ancient human capabilities. Each new discovery forces us to reconsider what ancient societies could achieve and how they adapted to changing environments. This understanding is particularly relevant as modern societies face similar challenges of climate change and rising sea levels. The impact on education and public engagement cannot be understated. Virtual reality technologies allow people to visit underwater archaeological sites, making this fascinating field accessible to everyone. How has this technological revolution changed public perception of archaeology and ancient history? The legacy of underwater civilizations has also influenced how we approach conservation and site preservation. The unique challenges of protecting submerged sites have led to innovative preservation techniques that benefit archaeology as a whole. These methods continue to evolve as we face new challenges in heritage preservation. As we look to the future, the legacy of underwater civilizations reminds us of the importance of continuing exploration and research. What other secrets might lie beneath the waves? How will future technologies enhance our ability to discover and study these sites? The answers to these questions will shape the future of marine archaeology and our understanding of human history. The impact of underwater civilizations on modern marine archaeology represents a continuing journey of discovery and innovation. As technology advances and our understanding grows, we can expect even more remarkable discoveries that will further transform our knowledge of human history and development. The legacy of these submerged societies continues to inspire new generations of archaeologists and researchers, ensuring that the secrets of our underwater past will continue to emerge and enlighten us about our shared human history.